to go.
Ready to rumble.
Yebo.
South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare and infrastructure and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Ngosikeleli Afrika Manupakanyisu Pondolwayo Izwa imithandazo yethu Ngosi sikelela Athina lusapho lwayo Murena buluka sichabasa Yesu Ufedise dintwali matwenye Usibuluke Usibuluke sichabasa Yesu sichabasa South Africa South Africa Ediblofa non seyem Editip tefanonsie Woronsie vetrechebet van die kruise aangekeerd. Sounds a call to come together, and united we shall stand. Let us live and strive for freedom in South Africa.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff. 30 minutes after the hour.
Good morning, goeiemorgen, molweni, ninjani, salamu alaikum, kaifa halukum. Say alhamdulillah. It's a great Sunday afternoon whereby we are doing the grade 11 Pure Maths workshop live from Glendale Secondary High School, Rocklands, Mitchell's Plain. We say welcome to you all, those who are here on the ground and those who are joining us live via our platforms, whether it be YouTube, whether it be TikTok, whether it be Instagram or Facebook. Welcome to Awqaf SA. It is the grade 11 Pure Maths. We are going to go straight to paper 2 according to Mr. Kota, and today we will be focusing on geometry. So do make sure that those who are online chat to us, ask questions, engage with us. Remember that you keep it respectful so that we can flight it online. If you're asking something that is out of order, obviously we are going to kick you out and you won't be able to comment any further. So do make sure that you interact with us and make sure that you are part of the lesson throughout. Learners on the ground, are you ready? We can double that up. Are you ready? And now we are going to call on learners from the Glendale Secondary School, learners that are hosting us here today, which will be led by Arshad Karelse, as well as Jordan Legranga, who they will talk to us here today. They will also do a prayer for us. So if I can invite you to please come to the front and render your statements.
Good morning, everyone. I'm going to start off with a prayer, and then it's going to go to Jordan, and then it's going to go to Asipi. Okay. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanirrahim. Maliki Yawmiddin. Iyaka na'budu wa iyaka nasta'in. Ihdina shiratal mustaqim. Shiratal ladzina an'amta 'alaihim. Khairu maghdubi 'alaihim waladdallin. Amin.
Let's bow our head, pray. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. For thine is the kingdom, the power, and the glory, forever and ever. Amen. Masithobeni inhloko sithandaze. Bawethu semazulwini, malingcwalise igama lakho. Umkani bakho mabufiki. Intando yakho mayenziwe emhlabeni, njengoba isenziwe emazulwini. Siphe namhlanje isonka sethu, semihla ngemihla. Usixolele izono zethu, njengoba nathi sibaxolela abasunayo thina. Ungasingenisi ebuyendweni, usisindise enkohlakalweni, ngoba ubumkani bobakho, namandla ngawakho, nomngcwalisa bobakho, kude kube naphakade. Amen.
Are you going to go first? Okay, you go first. Good morning, everyone. I'm just going to give a speech for the maths program. A warm welcome to all our guests from Awqaf, the department, our amazing teachers, and of course, all the bright and determined learners from the schools across the Cape. It's such an honor to stand here today as we begin day 2 of the Awqaf SA Maths program, right here at Glendale Secondary School, our home and now the home of opportunity for more than 300 learners. First, I want to say a huge thank you to Awqaf SA, the WCED, for trusting Glendale to host this incredible initiative. You've given us more than just a weekend of maths. You've given us a space to grow, to challenge ourselves, and to see that our efforts truly matter.
Yesterday we tackled paper 1, today we face paper 2, but we don't do it with fear, we do it with focus, faith and determination. Because this program is not just about numbers or formulas, it's about discipline, teamwork and growth. Yes, I know it's Sunday, we all could have been at home, but instead we chose to sacrifice our time for success. And that's what champions do. They pitch up when no one is around. So every learner watching online, sitting here, remember that you are part of something bigger. Every question you solve today brings you one step closer to your dream. Let's make day 2 even stronger than day 1. Let's show up that we are not just learners, but we are future leaders, innovators, and problem solvers. Once again, thank you to Awqaf SA and the WCED and our dedicated educators for guiding and believing in us. Thank you, everyone. Let's give it our all today.
Beautiful, beautiful, beautiful.
We say thank you very much to Jordan as well as Arshad. Do you know how to scream? Can you scream a little bit for them? Okay, I know gents don't scream. Because if Bakeba scream Hashem, so yes, but okay, after 9. So amajita akhona ngicela bethi fleti. Okay. Ungathi ni scream ukodlula bona. So ngicela niphinde ni scream nibafundisi bakwenzwa njani. Amajita ifleti ngicela ni responde. Okay, Mr. Kota, we are about to get going now. What is it that we need?
Right, good morning, good morning, good morning. Welcome everybody. I hope you guys are bright and fresh and early on this beautiful Sunday morning in the Western Cape. Taking a drive along the beach, coming here through Baden-Powell, I witnessed a beautiful, beautiful Cape morning. So I just want to say welcome to all our onliners, all our in-person learners from all the different schools. Guys, we got a big day today. I hope you've got your scientific calculators. I hope you've got your exam pads and your stationery and obviously your snacks, your munchies, and especially some hydration to keep you going through today's session. Guys, today is to prep you fully for paper 2. We lost a lot of time yesterday. And what we're going to do, I'm going to dive straight into the big topics that you're going to require to guarantee your 80 to 90% for paper 2. We have enough time, we'll finish probability, but we've done a lot of work yesterday for paper 1, enough to score you at least 90% for your paper. So we did algebra yesterday, we did the whole of functions yesterday, we've done the whole of finance, and we did number patterns. That's enough, like I said, to give you 90% for paper 1. Let's now go into paper 2. Now I've put up a diagram here, guys. Take this diagram. This is L, 0 and 3. Onliners, how are we doing? Welcome, welcome, welcome. Khalid, talk to us. Are the guys fired up? They can't tell me that they tired from yesterday.
We've got Inganati who's saying shout out to Tiru, and as well as Inganati saying a good morning to everyone. There's someone who is saying, and that's Sauda Basadin saying hi, and Jahid saying amen to those prayers. So a lot of the learners online are good to go.
Guys, you guys are all sacrificing and we appreciate the sacrifice. Remember that I am putting, or we as a team are putting in double the amount of effort that you are putting in. We did a grade 11 workshop yesterday, paper 1. Khalid, last night, I started at 7:30 till 2:30 a.m. with another cohort of online learners for grade 12. 2:30 a.m. Up at 5 and fresh and boosting, full of rocket fuel, ready to take away day 2, paper 2, grade 11, 2026.
Guess who's in the house?
Who?
Tanya Radzwa from Alu, the one
Oh,
who
wow,
was...
wow. Welcome, welcome, welcome. Guys, take this diagram down. Let's get into the grind. Put up the whiteboard there. Give us the whiteboard. Can we make this whiteboard like bigger, like the full size of the entire screen? Or is this the biggest that it can go? Okay. Right. For analytics, guys, you're going to get 2 questions. For 40 marks, 35 to 40 marks, you're going to get 2 questions in your exam if you're writing a common paper. If you're writing an internal paper, they might give you 1. But if you're writing a district paper or you're writing a national paper, then obviously you're going to get 2 questions, 20 marks, 20 marks. What are you going to be tested on? Here's our formulas. Number 1, grade 11s, your distance formula. So your distance formula between A and B or B and C, any 2 points, we all know. Please, you need to remember this for grade 11 and 12. x2 minus x1 all squared plus y2 minus y1 all squared. We use the distance formula to calculate the length of a line or the radius of a circle if a circle is given. We also use it to prove shapes. So if they want you to prove it to be a parallelogram or a square or a rhombus, you can use a distance formula as well. Number 2, formula number 2, you all know the gradient formula. The M of AB. Now this is a very important formula. We all know y2 minus y1 over x2 minus x1. Yes or no? Right, now you tell me, where do we use the gradient? Obviously we use the gradient formula for finding the gradient for an equation of a straight line. Yes or no? Right. What else do we use the gradient formula for? To prove parallel lines. There we know that the gradient, the m of line 1 must equal to the m of line 2. Yes or no? Perpendicular on 90-degree lines. What's the formula there? The m of line 1 multiplied by the m of line 2 must equal to minus 1. Collinear points. What does collinear mean? Straight line. Do the points lie in a straight line? So if they say prove that A, B, and C are collinear, A, B, and C, we need to prove that the gradient between these two is equal to the gradient between those two. Very important, these formulas, and when to use them. Then we use the gradient formula for one more. Which one is it? Who can tell me? How about the angle of inclination? The angle of inclination. And what formula do we use there? Tan, very good. We use tan theta, that's your angle of inclination, is equal to the gradient of the line that it touches. We have another formula, the midpoint formula. We all know the midpoint formula. X midpoint is equal to x1 plus x2 over 2, and y midpoint is equal to y1 plus y2 over 2. There we go. There we go. Here are our formulas. And then we got one more, y is equal to mx plus c, the equation of a straight line. Excellent. Excellent. Onliners, how are we doing there? Khalid, talk to us. How's our guys doing there online?
We've got Delft High, in the house as well, with Solomon saying shout out to Messi. I don't know who's Messi.
Come guys, take these formulas down and let's get cracking with the questions now. There's a diagram on the left-hand side. We're going to use that as a model. It's from a past paper. This is, I think, Northwest, final paper 2024. Yes, Northwest, November 2024. But it's not important. That's just for information. I am going to put up all the questions on the screen. And like we said, those of you who haven't joined us yesterday, that these sessions are recorded live on YouTube, on Awqaf SA. AWQAF SA, grade 11 math. You'll see today's workshop on there. And you can always go back, refresh, try all the questions, and prep yourself for your finals. Okay, so you've got your formulas down. Onliners, are we on fire there?
The Westbury Secondary School is here.
Wow.
A shout out to Masipumelele High from Dominic.
Okay, I'm erasing the formulas, guys. You know the formulas now. I'm erasing them. Let's start with questions based on this diagram. Now, as you can see, there's a quadrilateral, KLMN, not a parallelogram, just a quad. There's angle alpha, angle beta, angle theta. You got a straight line here. You got a straight line here. You got KNMN. Okay, here we go. Let's start with the questions. All we have to do is apply the formula. So question number 1, and I'm sure we all can do that. This is marks for free. The gradient of Kn. Question number 1, they want the gradient of Kn. The gradient of Kn. So we have to look at K's coordinates and N's coordinates. 2 marks there. Very simple, straightforward. Yes? Oh yes, it's -3 here. There we go. That's -3. Thank you. Right. The gradient of Kn. So we're looking at this line here. We're looking at this line here. So you say the m of Kn. Because they're specifically asking you for the gradient, put in the formula. y2 minus y1 over x2 minus x1. Now you can call any one x1, y1 and other one x2, y2. Let's call this x2, y2. So y2 minus y1 minus minus 2 plus 2 over x2 minus x1. So this is equal to minus 6 plus 2 is -4 over 9 minus 7 is 2. Obviously, your answer is -2. So the m of this line is equal to -2. So you go to your diagram, once you got your answer, and you throw your answer onto the diagram, once you're happy, satisfied with your answer. Question number 2. Determine the equation of the straight line Kn. Number 2, question number 2, they want the equation of the straight line Kn. So now they want the equation of this line. Now we got the gradient, and we can use any one point. Now, okay, put your pens down. There is a long way of doing it, which is y is equal to mx plus e. That's the long way. I got a nice way also that will give you y is equal to mx plus e, but a better way. Right? That's why you sacrifice your Sundays, to come and see lekker ways. Right? So let's do this. Let's answer the equation of Kn. Number 2, They want the equation EQTN, just abbreviation, equation of Kn. Right. How many of you have seen this formula before? Y minus Y1 equals M into X minus X1. Some of you have seen it? Lovely. Now, whenever you're given the gradient and one pair of coordinates, you can use this to find y is equal to mx plus c. So whenever you're given the gradient and any one point, right, so you can use this coordinate or you can use k. Let's use the 9 and the minus 6. And we've got the gradient. So there we go, guys. We've got the gradient, we've got a point. So y minus y1, let's all substitute correctly. Y minus minus 6, y plus 6. Yes or no? Work with me here. Is equal to m. What's m? Minus 2 into x minus 9. Are you all with me? Let's remove the brackets on this side. Y plus 6 is equal to minus 2x plus 18. Here's your final answer coming up. Y equals minus 2x plus 18 minus 6 plus 12. So y equals minus 2x plus 12. So here we go. Y equals minus 2x plus 12. For those of you who are done with it, you can start with the next one. Calculate B, beta, the angle of inclination. Calculate angle beta. Now it's very easy. I'll show you how it's done if you don't know. There's angle beta on the top. Calculate angle beta. Now you know the gradient of this straight line here. The m of this line here. The m of this line is equal to minus 2. Right, there's too much talking at the back, guys. Okay, let's do number 3. Calculate angle beta. Check this out, guys. Let's do it together. Very important. Question number 3. So we're going to say tan beta is equal to the m of line Kn. It's the same line. So the gradient at the bottom of this line is the same as the gradient on the top of the line. Pay attention. So tan beta is equal to, what did we calculate the gradient to be, guys? Right, so watch here. So you put minus 2. So beta is equal to, let's go to our calculator. Shift tan minus 2. Shift tan minus 2. I get minus 63,43. Now remember, 63,43 is the acute part of this complete line. 63,43 is less than 90, so that is 63,43 on this side of the line. We want that side. We want the obtuse. We know angles on a straight line add up to how much? 180. So in this case, because we got 63,43, which is acute, we want an obtuse. Beta is obtuse. Beta is obtuse. So obviously I'm going to say beta equals, because you get, I'm just going to add 180 to it. So add 180 to this, minus 63,43 plus 180 degrees, adjacent supplementary, angles on a straight line add up to 180. Or you can just say 180 minus 63,43, no problem. 180 minus 63,4, what do we get? 116,6. So angle beta is 116,6. Why did we add 180 to it? Why did we add 180? Because 63,43 gave me the acute part of this. We wanted the obtuse part of it. The next question. Now let's see if you guys can do this. Calculate angle alpha. Now alpha is hanging in the air. Alpha is not against your x-axis. Now that's 5 marks. Let's see how you get to angle alpha. Where's angle alpha? Where is angle alpha? Angle alpha is here. That's angle alpha. Come, I'll give you a couple of seconds to try and figure it out. It's not difficult at all. Must I give you a clue? Do you want a clue? Right, so here's a clue. Watch here. There's a triangle. Here's a triangle. And if this is angle theta, then that is angle theta, vertically opposite. And an exterior angle is equal to sum of interior opposite angles. We can do it like that. So you got beta, find angle theta. To get alpha, you need to find angle theta first. You need to find angle theta because this angle and that angle are vertically opposite. This forms part of a triangle. Sum of angles of a triangle add up to how much, guys? 180 degrees. Onliners, how are we doing? Khalid, talk to us. Are they boosting with us? Are they on fire with us? Are they getting it right? Remember, today will tell you exactly how ready you are. Today will tell you exactly how ready you are for your exams. Come, guys. So let's find angle theta, guys. The question says find angle alpha. So here's the question, question number 4. For 5 marks, find angle alpha. Was it 5 marks? 4 marks. Right, the first thing we're going to do is find angle theta. So tan of angle theta is equal to the m. Which line does this arrow touch? From your x-axis up, which line does it touch? KL, because it's a straight line. The gradient on the top is the same as the gradient at the bottom. So now we say the m of KL, the angle of inclination. So tan of theta, we don't have the m of KL. Let's find it. Let's find it. y2 minus y1 over x2 minus x1. So tan of angle theta is equal to 1 over 7. Angle theta equals, let's check if we get an, we know theta is acute. So if I get an acute answer, I leave it. If I get an obtuse answer, I say 180 minus. Yes or no? Correct. So let's see. We always use tan. We never use sine, we never use cos. Shift tan 1 over 7. Why are we using shift? Second function on a calculator? Because we're looking for an angle. Because we're looking for an angle. Whenever you're looking for an angle, you use the shift key. We get 8,13. 8,1 degrees. That's 8,1. So this angle here is also 8,1 vertically opposite. Yes or no? Right. These two angles are vertically opposite. So if this is 8,1 then this angle here inside the triangle is also 8,1. Now we got a triangle. Exterior angle is equal to the sum of the interior opposite angles. Yes? Sorry? 8,13. No, you can do it to 1 decimal place. Degrees we generally do to 1 decimal place. Sides we do for 2. You know what is a degree? A degree is 1 millimeter. So when you go to 1 decimal place, you're going to a tenth of 1 millimeter or 1 degree. You know, now when you're going to 2 and 3 and 4, you're going to 100. I think it only matters like a second. I mean, I think in Formula 1, where they go to 1,000th of a second. 1,000th of a second. That's how accurate when you're dealing with high speed, like 300 kilometers per hour or 350 kilometers per hour, like Formula 1. But when we're dealing with this here, 1 degree and tenth of a degree, it's negligible. So we don't need to go to 2 decimal, 3 decimal, 4, 1 decimal place for degrees, you sharp. But for a side, a length of a line, we generally go to 2 decimal places. Right. So if you want to put a 3 here, you're welcome to put a 3. If you got 8,13 and you want to put 8,13, no problem. Full marks for you. Right. Now we need to find angle alpha. The question said find angle alpha. So now angle beta is equal to alpha plus theta. Why? This angle beta outside is equal to alpha plus theta. Why? Exterior angle of triangle is equal to the sum of the interior opposite angles. Yes or no? Yes. So what is angle B? We found angle beta is how much? 116,6. We want angle alpha, so we leave it out. We got angle theta to be how much? 8, so how much is alpha? Let's take this on the other side. 116,6 minus 8,1 is equal to angle alpha. So angle alpha is equal to, let's go to our calculators. 116,6 minus 8,1. Boom. Here's our final answer coming up. 108,5. And you'll get full marks for that. Yes or no, guys? Right. Show the next, okay, you've taken, for those of you who have taken this one down, let's put the next question up. Question number 5. Show that KL is perpendicular on 90 degrees to KM. Probably 3 marks. Okay, 2 marks. Here we go. KLMN. Cyclic. KL perpendicular. Where's KL? KL perpendicular to M. KM. KL perpendicular to KM. KL perpendicular, so probably that must be 90 degrees. We need to prove that it's 90 degrees. Or maybe 90 degrees, which way? Yes. KL and KM, guys. So KL, this line here. KM is this line here. How will we prove? Let's find the 2 gradients. Let's find the gradient of this line. Let's find the gradient of that line. Let's multiply the gradients. And what must my answer be? -1. So try it. See. Check if it works out. Check if it works out. Now the next one is going to bring in a little bit of Euclidean into this. And the next one is worth 5 to 6 marks. So let's first KL. Do we have the gradient of KL? Did we work the gradient of KL out? We did, am I right? The M of KL in the previous question was how much? 1/7. The M of Km, let's check. Y2 minus Y1 over X2 minus X1. I'm using that one's coordinates and M's coordinates. So M of Km is equal to 7 over minus 1. The M of Km equals minus 7. Now, the M of KL multiplied by the M of Km is equal to 1/7 times minus 7/1. What's my final answer? Therefore, KL is perpendicular to Km. So that means that's 90 degrees. Yes or no, grade 11s? Yes. Now the next question is super interesting. Prove that KLMN is cyclic. In analytics, they're bringing Euclidean in. Prove that KLMN is cyclic. Onliners, Khalid, where's my man Khalid? How are we doing there? How's our onliners doing? Hasanain, talk to us. How's our comments coming in? How's our onliners doing there, guys?
It's all good, Mr. Kota. We're cooking with gas here. Got a really engaged audience. They're very appreciative that we started on time, and I think we're doing good for time today. What do you say, Mr. Kota?
Yes, we're going to... Absolutely. I'm going to do this. We're going to do one more on this. And prove that KLMN is a cyclic quadrilateral or is cyclic for 6 marks.
Shout out to Mango Fish, the legend.
Back in
KZN.
The man, the myth, the legend.
What if it's a female, Kota?
Sorry?
What if it's a female? Mango Fish.
Yeah? The woman, the myth, the legend.
Shout out to Aquila, Hello High School. And we get this recurring one. Shout out to Solomon. Solomon wants some infamy or you want some fame. So shout out to you. Robin says, we love you, Mr. K.
Yeah, we love you too. We love you too. Guys, grade 11s, it was amazing. You must see the comments that came from last night's grade 12 workshop. Do you know how appreciative they were? They only put crying faces on the WhatsApp chat. We had a group of, a cohort of about 60 to 70 learners, grade 12s. We were only supposed to go until 11 p.m. We ended up going till 1:30 a.m. Okay. So and I'm telling you, they couldn't be more, their parents this morning, when I opened up my WhatsApp, it was flooded with thank yous. So yes, that's what gives us our fuel in order to get up at 5 in the morning, sleep at 2, and do more maths for the day. So guys, we love you. We want you to be successful. We want you to make a change in your life. You be the change in your family's life. Correct. We had so many incidences in the past, Hasanain, where learners had no hope of passing. They attended our workshop. They came in, a light bulb went on in their mind.
It's what you put in. It's what you put in the box.
And they went home and they got so inspired through the workshops and they finally saw the light. And okay, Obviously, immediately after the workshop, they didn't get an A, but it activated something in them. It lit that fuel in them. And within a period of 2 months, they scored 85% in their finals. From failing, from absolutely being blank. And there are hundreds of success stories like that, not just one. So all of you can do it. I promise you, you can.
It can be done.
Right. Now I know they're listening to all the chit-chat because they don't want to tackle the next one. They're waiting for me to do it. They haven't even started with this one.
So mango fish is a
Okay, I say start, you say start. You haven't even started with it.
You kuzaring us, eh? You kuzaring us, Cape
Go
Town
start
people.
the car. Go start the car.
For your record, mango fish is male, eh?
Yeah. Here we go. Here we go. Now watch here. Now, in order to prove grade 11s, you need to pay attention now. Chit-chat is over. Pay attention. In order to prove this to be a cyclic quadrilateral, that means a circle can be drawn around it, and all 4 points must touch the circumference. Now, there are only 2 ways to prove it. One, exterior angle must equal to interior opposite. So that means this angle K here on the outside must equal to the whole of angle M. But that's going to be a story because we need to find angle M. And angle M is going to be a lot of work. So let's rule that method out. What is the other method that we can use? How about this butterfly method, the bow tie method? If I can prove that this is 90 degrees, then won't this be angles in the same segment? Yes or no? And I think I'm going to go, let's go and use that method. I'm going to use this method. I'm going to prove that this angle is 90 degrees. If I can do that, game over. Then we'll say converse of angles of the same segment are equal, therefore it's cyclic. Right, now pay attention. Let's now go and find, to prove this to be 90, we need to find the M of Ln. The M of Ln equals y2 minus y1 over x2 minus x1. So M of Ln equals 3 over minus 9. M of Ln equals minus 1 over 3. Now that means we need to find the gradient now of Mn. I found the gradient. I just worked out the gradient of this line here. The gradient of that line, we just calculated it now. The M of this line is equal to minus a third. I must get the gradient of this line here to be 3. I must get the gradient to be 3, because 3 times minus a third will give me minus 1. Yes or no? So let's do it together. The M of Mn. The M of Mn is y2 minus 9 plus 9. There's the 3, and I must get a 1 at the bottom. Here we go. Over y2 minus y1 over x2 minus x1. The M of Mn is equal to 3 over 1. So the M of Mn is equal to 3. Therefore, the M of Ln multiplied by the M of Mn equals minus 1. Therefore, Ln is perpendicular or 90 degrees to Mn. So if this is 90 degrees and that is 90 degrees, therefore, now you can, you can even say, but angle LKM is equal to 90, proven above in the previous question. Therefore, KLMN is cyclic. It's a cyclic quadrilateral. Why is it cyclic? The circle is not given. If the circle is given, you say angles in the same segment. If the circle is not given and you got to prove it to be cyclic, we don't say angles in the same segment, we say converse. What do we say as a reason? Converse of angles in the same segment of a cyclic quad. And there we go. We've now proven it to be cyclic.
Shout out to Anna from Portland High School. We had Portland High School last week, Kota, for the grade 12.
Yes, that was
workshop.
amazing, guys. I'm telling you, we're traveling Cape Town. We going corner to corner. Understand, grade 11s, that you are matriculants. The same question like this will appear in a matric final paper. The same model. Nothing will change. Absolutely nothing will change. You will see. You can start prepping on your final for grade 11 with grade 12 past papers on analytics. You'll be able to do it comfortably. There was anything in normal analytics. Shh.
Mr. Kota, we need to take your contraband out of the shot because Red Bull's not paying us royalties for this live stream, unfortunately.
I get wrapped on my knuckles for everything. Well, I'm in a naughty boy corner every workshop.
Yeah, man, you must
If it's
boost
not
with
for my
other guests.
language, it's for my behavior. If it's not for my behavior, it's for my drink. What do you want from me, like?
I want you to sing for us today, man. Come on now, Kota. Later on, later
Do you
on.
want my kidney, bruh?
No, no, no,
My
no.
left,
I want you to
my,
sing for
my
us
left
later.
lung.
Oh, no, not your lungs. Camel lungs.
I can't deal with these guys anymore. I'm done. I love you guys. Okay. Yo, Hasanin, you just killed my whole flow, bruh. I was boosting.
Yeah, you were boosting, but not with that contraband there. We're not giving free advertising.
I was
to them
like
on the
that.
live
I was
stream.
like that SpaceX rocket that took off, and everybody's watching it. Everybody's now cheering it on, and there's it part. The whole thing bursts into flames.
You need to be with us commoners on the ground, Mr. Kota.
Yes, so grade 11s, as I was saying, back to my point before, Hasanin came and interrupted me so beautifully, gracefully,
Elegantly.
elegantly,
Yeah.
that grade 11s, you are able to do grade 12. Analytics, it's the same. Only thing in grade 12, you'll be given one new topic called circle analytics, which is a separate topic, a separate 20 marks. But under analytics, you can start prepping from grade 12 papers already. Right, let's go. Let's do one more. Another model from the same paper. So like I said, how many analytics questions were there? 2. Again, I'm telling you, this is Northwest 2024. But we're just using it as a template. So there are various sites. Please, guys, I beg you, after you understand your work and you know what you're doing, what's your next step? Past papers. And guys, don't study alone. Always study in a small group. 2 or 3 of you. But please, even when you choose your groups, you can't choose 3 domcops. You all will fail. You will fail beautifully, gracefully. It will be the blind leading the blind. Please, when you're choosing your group, if you 4 of you, at least 1 or 2 of them in the group must be, amped, and it must be A student. Bruh, when you're parking with 3 30%ers, you are in a cut. And the beauty part, you'll always get the one who's getting 18%, wanting to do the higher order and explaining the higher order to everybody. Bruh, you don't know your basics. You don't know your quadratic formula. You want to now go into higher order stuff, bruh. Kills me. Onliners, choose your groups well, your study groups. It's not about choosing your bras, it's choosing those who's going to get you to your destination. Your bras are there with you for a good time. You need to choose people who's going to get you to your destination.
When days are dark, friends are few.
When days are dark, friends are few, brah. How's our onliners doing there? Asanain, are they choosing good groups? Or are they choosing out of 4, 3 domkops? Calculate the coordinates of t, right? Number 1. Point T lies on the perpendicular by... now they tell us, check this information. Point T lies on the perpendicular. Asanain, how's our onliners there? Are they talking to us? Are they vibing with us?
Mango fish reckons must get sharp bras.
Yeah, get sharp, bras.
Follow me for more tips.
Follow me for more tips. You are the sum average. You are the sum average. You are the mean average. Sum of your data divided by your number. You are the sum average. You are the mean average of the 3 or 4 people that are closest to you that you hang around with. Understand that. Like Andrew Tate says, you can't go and take financial advice from a brokey. Bruh, if people are broke, how can they give you financial advice? You need to sit with millionaires to give you millionaire and billionaire advice. So if you want to pass math, you've got to sit with people who are mathematically activated. Otherwise, now no downloading is going to take place. Right, question number 1. Calculate the coordinates of T, the midpoint of PR. Question number 1. They want the coordinates of T, the midpoint of PR. You can start with this one already. Number 2, the length of PR. Guys, when we're done with this block of questions, we're done with this. Then we're moving into trigs. Leave your answer in third form. Determine the equation of ST. Find the equation of ST. If ST is perpendicular to PR, if ST is perpendicular to PR, and the M of PR and M of PR equals -1. Number 4. Hence prove that A equals B. That means that and that must be the same coordinates. Now the last question, the last one. I can't say last, then they know you're from Joburg. If the area of triangle PRS is 12, let's put question number 5 here at the bottom. Now they're talking about area. If the area of triangle PRS is equal to 12 units, 12 square units, and A and B less than 0, find the coordinates of S. For 5 marks. So let's give you your mark allocation here. The last one's worth 5. 2, 2, 3, 1, 5. 2, 2, 3, 1, 5. Right, go for it. You guys can start so long. Don't wait on me. While I already open up trigonometry, I'm going to start looking now for some nice trig problems for you to do. The last one's big. The last one for 5 marks is huge. But don't panic. This is your higher order question. So that means if you got 2 and 2, that's 4, and 3 is 7, and 1 is 8, and you got full marks for the previous 20, you already got 28 out of 33 marks. But you're going to try doing the last one. You have to give it a go. But don't spend too much time. If you see, hey, more than 5 minutes, 6 minutes.
Mr. Kota, just be mindful with the tech regarding your whiteboard.
Yeah.
There is a scroll bar on the right-hand side there. So you just need to scroll a little bit up so our learners can view that.
It's clear. You guys can see everything, am I right, at the moment?
No, but find the coordinates of S. This is where we're cutting off. So you need to scroll up.
So must I go a little down, like that?
Yeah, go down a little.
Good. Are we all right there?
Yeah, just thank you.
Okay.
Let the tech work with us, not against us.
Yes, boss. Who am I to complain?
Salute.
Yes, sir. Okay. Point T lies on the perpendicular bisector of PR. The answer to question number 1. The answer to question number 1. The coordinates of T, the midpoint of PR. The midpoint of PR. That's T. And they say perpendicular bisector. The minute they say that, perpendicular, drop a perpendicular. So not only is it at the midpoint of this line, bisector, cuts into 2 equal parts, it's also perpendicular, it's also 90 degrees. And they're telling you the coordinates of T, if T is the midpoint of PR. So they even helped you along the way. They could have made it more difficult for you and not told you it's a midpoint, just said perpendicular bisector. You would have had to know that bisector means to cut into 2 equal parts. Right. So obviously we're going to use the midpoint formula, am I right? Right. Let's do the answer to question number 1. So let's do this. Let's split this up. These are our questions. Here's our answers. Right. So to get these coordinates, x1 plus x over 2, y1 plus y2 over 2. So T's coordinates would be x1 plus x2 over 2, y1 plus y2, we don't change the sign because it's positive, over 2. So we got t is equal to minus 1 plus 3 is how much? 2. 2 over 2 is 1. 3 minus 1 is 2. You see, 3 minus 1 is 1. So nice. 3 minus 1 is, and 2 divided by 2 is, so your coordinates is 1 and 1. Did you guys get that one right? Well done. The next one, the length of PR. The length of PR. That's easy. We're going to use the distance formula. Now they're telling you to calculate all these small things because it will be used later in the big one. How's our time? 20 to 10 already. Right, let's do PR. Answer to question number 2. PR is equal to, you must put the formula in, you get a mark for it. x2 minus x1 all squared plus y2 minus y1 all squared. That's your distance formula for length. So the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So PR is equal to the square root of 4 squared is 16 plus minus 4 squared is 16. So PR is equal to the square root of 32. So PR, they want it in simplest third form. Go to your calculator, just say square root 32 equals, you get 4 root 2. That's the same. So the length of this line is 4 square root 2. That's the length of the line, units. PR, we don't say centimeters, we don't say meters, we don't say millimeters, we say units. In analytics, we say units. Now, do number 3 and 4. Onliners, how are we doing there? Khalid, talk to us. How are they doing? Are they boosting with us? Are they getting it right?
They're getting cooked, Mr. Kota.
No, they're cooking. I think they're cooking. They're not getting cooked. It's easy stuff. It's straightforward stuff. The last one is the only tough one. The last one, you're going to have to use a little bit of brains. But everything else, right, so there we go. We're done with that, done with that, done with that. Let's do question number 3, 4, 5. The equation of ST, where's ST? That's this line here. If ST is perpendicular to PR, yes it is. It's perpendicular to PR. And the M of PR equals minus 1. So the M of PR, they're telling us that the gradient of this line is equal to minus 1. So they want the equation of a straight line. So number 3, the equation of a straight line, we got the, so the M of ST will equal to 1. The M of this line will equal to 1. Why? Because ST is perpendicular to PR. The M of line 1 times the M of line 2 is equal to minus 1. Now we got the gradient and we got a point. So again, we go back to that formula I gave you earlier, guys. What was that formula to find the equation of a straight line? Y minus y1 equals m into x minus x1. And we got a point 1 and 1. We got a point 1 and 1, and we got the gradient. We got the gradient. So y minus 1 equals m, which is 1, into x minus 1. So y minus 1 equals x minus 1. Take the minus 1 on the other side, will become plus 1. What's your answer? Y equals x. That means the equation of this line here is y equal x. What is the equation of that line? Y equal x. Now, look how easy the next question is. Prove that A equal B. Obviously, you got the equation. So, I'm answering question number 4 now. Prove that A equals to B. Question number 4. Let's just do it here on the side. Prove that A equals B. So, you got the line Y equal X. So therefore, this point here, so if I put in y, we got it here, watch here, what's y? We got S's coordinates A and B, X and Y. And it lies on that line, so I can just substitute it. What's y? What is y, guys? B. What is x? There's it. B equals A, therefore A equals B. You just substitute it into the equation of that line. Isn't that the purpose of an equation? If I substitute the x, I can get y. Or if I substitute the y, I can get. Or if x and y are given, I can plug them both in. So here we go. For those of you who didn't get that one, let's do it one more time. You got the equation of the line y equal x. You just found that out. You got the equation y equal x. You got S's coordinates which lies on this line, A and B. So that's x and that's y. So here we go. Here we go. What is y? What is y? B. What is x? A. So they said prove A equal B. Therefore, whether you say B equal A or you say A equal B is the same thing. Now comes the last one. If the area of triangle PRS is 12 units squared, find the coordinates of S. Very interesting question. I want you to apply your minds. I want you to apply your minds. Don't wait for me to give you the final answer. They're talking about area, and there's a perpendicular height. So we're not using the area rule from trigonometry. We're not going to say half of a side times sine of the included angle. No, we're not touching that because we got a perpendicular line. So we can just strictly stick to what? Half base times perpendicular height. I'm just giving you a clue. I'm guiding you along the way. Come, I'll give you guys 2 minutes. That's the name. Khalid, how's our onliners doing? Are they on fire? Are they working? Okay, the last one, it is a higher order question. I'm expecting it to be a little bit challenging, not too much. I promise you when I explain it to you, you're going to see it as clear as daylight. But come on, the clues are there. The writing is on the wall. They're talking about area and they're giving you the area. They want the coordinates of S for 5 marks. How's our onliners doing? Are they winning?
Someone is asking, why are the coordinates of P changing signs?
Why? The coordinates of
P.
P or B.
They wrote P here.
Why is the coordinate? I'm not.
Maybe they are left behind here.
Remember, we just proved that A equals B. That A, whatever A is, B is the same thing, or whatever B is, A is the same thing. We just proved that now in the last question. So area is equal to half base times perpendicular height. Yes or no? We're now talking about triangle PRS. We talk the area of triangle PRS is equal to half base times perpendicular height. Come, go ahead. Do it on your own, guys. It's a brilliant question. Absolutely amazing. You'll see once we start working it out. You have to apply your mind. Remember, you are future mathematicians. You've got to use your analytical skills. You've got to use all the tools that you have at your disposal. It's lots of fun to do this one. Don't let it beat you, guys. Don't let it beat you. Don't just look at it and say, I'm beat. Right, so 12, watch here. 12 area, they gave it to you, is equal to half your base. You worked it out, 4 root 2 earlier on, times your perpendicular height. What's your perpendicular height? Isn't it ST? Yes or no? Do you have ST's length? No. Can you find ST's length? Okay, watch here. Multiplied by, so your perpendicular height is ST. So that is, and what is ST equal to? The square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, we're talking about ST, the perpendicular height, the 90-degree height. Now pay attention. Pay attention. Oh, that went a bit loud. Okay, let's go. 12 equals a half of 4 is 2, square root 2, multiplied by the square root of x2 minus x1. So we're talking about ST now. Pay attention. Pay attention. Onliners, on-siters, bums on seats, eyeballs on screens. x2 minus x1 all squared plus y2 minus y1 all squared. Yes or no? But what did we prove in the previous one? Isn't A equal B? But B equals A or A equals B, same thing. Now watch, but B equals A. Here comes the fun. Here comes the fun. Now the fun starts. We want the coordinates of S. Watch here. Watch here, guys. And this is grade 11 and 12. You will see stuff like this next year too. So if you practice on this, you get varam now, you become an acer in math now, you're going to be an ace in math next year. So 12 is equal to 2 root 2 multiplied by, instead of b, what can I put? So watch here, a minus 1 squared plus a minus 1 squared. Yes or no? Right. So let's divide this side by 2 root 2. Let's divide that side by 2 root 2. Boom, boom. So let's get that out of the way. So 12 divided by 2 root 2 gives you how much? 3 root 2. 2 goes into 6. So your answer, 12 divided by 2 root 2 is 3 root 2 is equal to the square root. Watch here, watch here, watch here. Now we are removing the brackets here. So that's a squared minus 2a plus 1 plus another a squared minus 2a plus 1. So 3 root 2 is equal to the square root of a squared plus a squared, 2a squared. Minus 2a minus 2a, minus 4a. Plus 1 plus 2. Don't you see a quadratic equation coming up? Don't you see a quadratic equation coming up? Like what we did yesterday where we had to square both sides to solve for a. Do you see it happening? Now watch. Okay, continue from here. I've just helped you along the way. It's a flippin' Picasso, Da Vinci, Van Gogh, work of art, Mona Lisa of math. A flippin' work of art. It's beautiful. Whoever came up with this question got a brilliant mind. There's clever people in the world, guys. They are. And the world is moving in such a way that the world is only going to be left for the intelligent people, guys. You need to be intelligent in life. Nobody says, I'm not saying that if you don't get into university, you are unsuccessful. No, that's not what I'm saying at all. Intelligence is a personal thing, guys. And the world is moving at such a fast pace that a huge 70% of 80% of humanity is going to be left behind. 20%, 10% of the world are going to activate and are going to move with the new trends, going towards AI, going towards all the new fields that are. AI is going to replace most jobs. But you need to be smart. There's always a place for every human on this earth. And there's always an opportunity for every single one. But it's up to you to find that opportunity. You find the gap, get into the gap, and survive through the gap. But you'll make it. But you've got to have a good head on your shoulders. You've got to have a solid head on your shoulders. Look at our highly intelligent tech team that we have here. Samit and team, mashallah. Intelligent people do intelligent things and make big things happen, right, Samit? Clever people do clever things. And nobody is born clever. You make yourself clever. You can rot, you can choose to sit at home and rot, become a vegetable. Or you can choose to activate. Choice is yours. Choice is yours. Let's continue. Remember something, each one of you, Each one of you, it's like you are a high-tech cell phone or computer. You are a supercomputer. God has created you a supercomputer. But if your computer or your cell phone is just sitting there, you don't switch it on, you don't activate it and don't use it, of what use is it? Useless. Collect dust. Right, we're done there. Let's now solve for A. We want the coordinates of S. So if I find A equals B, that means I can find A and B. I'm just writing it here on the top. 3 root 2 is equal to the square root. I'm copying and pasting it here on the top. 2A squared minus 4A plus 2. Right, now we're going to square this side like we did in algebra, and we're going to square that side. 3 squared is 9 times 2. Did you all get that? Yes or no? Well done. Is equal to that, and that will cancel out. What are you left with? 2A squared minus 4A plus 2. Now, quadratic equation. 2A squared minus 4A plus 2 minus 18. 9 times 2 is 18. Comes on the other side as minus 18 equals 0. 2A squared minus 4A minus 16 equals 0. Now divide by 2, it's an equation. A squared, I'm dividing everything by 2, minus 2A minus 8 equals 0. Let's break that up equal to 0. A minus 4, A plus 2, A equals 4, or A equals minus 2. Yes or no? But it's to the left. A is to the left of 0. Can it be positive? No. So A is equal to minus 2. So S's coordinates, the A coordinate is minus 2. And A equal B. We just proved it above. Therefore, B is also equal to minus 2. Therefore, S's coordinates is minus 2 and minus 2. Flippin' brilliant question. Absolutely amazing. Guys, onliners, did you guys get this one? Onliners, did you guys get this one? Have you got any -2 and -2s coming up there, Khalid?
Liam got it. And
Beautiful.
Mango Fish.
Congratulate them.
And Nabila Isak as well.
Nabila Esak, well done, Nabs. Well done. Well done. Brilliant. Okay, we are 10 o'clock on the dot. We're going to 10 o'clock on the dot. Let's just start you off with some trigonometry. You guys hungry? You tired? Brains fried? Not yet. Not yet. You guys want to go for a coffee break? And then we come back and do trigs. We're moving on very good time. Are you okay, or you want me to carry on with trigs? How many of you, show of hands, how many of you say 20-minute break? Okay, so nobody. Beautiful. Guys are boosting here. Yo. Owens, don't want break, bruh. Right. Trigonometry, here is your checklist, what you need to know. Number 1, you need to know how to simplify. Okay, the first thing is how to do your Cartesian plane. Cartesian plane. Sokotoa. Right, number 2, reduction, to simplify without the use of a calculator. Special angles. Number 3, identities, proving left-hand side equal to right-hand side. The question will say prove. Number 4, trig substitution. Like this, if they tell you if sine 21 equals P, find blah, blah, blah in terms of P. Number 5, general solution. Number 6, 2D trigs. Trigs on different planes. Number 7, trig graphs. Now all this in total is plus minus 40 marks. Everything in total, and you're going to get one of each. In your exam, you're going to get one of this. You might get two of this. You'll get one identity. So one day, you might get one or you might get two reductions. You'll get one identity. You'll get one of this. You'll get one general solution. You'll get one 2D trigs. Take this down. This is your checklist. Trig graphs, you're going to get one model, but look, obviously trig graphs, you need to know your sine graph, your cos graph, your tan graph. You need to know how to sketch. You need to know how to find equations. You need to know how to give the amplitude of the graph. You need to know how to give the maximum value of a graph. You need to know how to give the domain, the range, the period of a graph. Where is f of, it's same like functions. Where is f of x greater than g of x? Where is f of x equal to g of x? Etc. So this is your entire trigonometry, as this is going to be your personal checklist to check whether you know trigs. You need to master each of these concepts. Math is a huge field, but if you compress it, you know exactly what you need to know in each topic, it becomes manageable. You know the old saying, and the saying they use it all the time, whether it's in corporate or whether it's, how do you eat an elephant? How do you eat an elephant? One bite at a time. So how do you kill? How do you eat the elephant of math? One topic at a time, one law at a time, one workshop at a time, one past paper at a time, 1 hour at a time that you are working at home, one bite at a time. Don't try and do everything. Now it's all about understanding. Now you break it up and you start mastering each component. These are components. Are we good? Summit, how's our onliners doing there? The comments still coming in? They still live? I don't see the whiteboard on here. What's happening here? It says here lost connection. Who? He. But you good on there. You're still getting all the comments there. So now I got nobody to give. Khalid, come talk to me here. Okay. I want to show you, I think something I forgot to show you yesterday. And now it came to my mind when we were talking. So if they told you, watch this. You know in functions, if they told you that f of x is equal to x squared minus 6x minus 10, find the minimum or maximum value of the function. I'm just going back quickly before I start with trigs. I want to show you something from algebra quickly. Right, so now we need to complete the square. How do we need to do it? We need to get it in the form A. We need to get it in the form A into x minus p all squared plus q. And the q value is your minimum or your... Right. Now how do we do this? We need to complete the square. What do we need to do? Complete the square. Now I'm going to show you a shortcut of completing the square. So shortcut time. Right. So we got y or f of x. Let's go here. Let's say f of x is equal to, watch here. We need to complete the square. So what you do, you took out the square. You took out the square. So what are you left with? What are you left with? X minus. Put a minus. Now we need a number here and we need a number here. A into x minus p all squared plus q. I'm showing you a shortcut to completing the square. Pay attention. So here we go. X squared. We took out the square there, so what am I left with? X. Are you all with me so far? Now watch here. There's a minus. There's a minus. If that was a plus, you'll put a plus. Same sign. Divide the coefficient of x by 2 minus whatever you divided by 2, you square it. So what's the rule? Divide by 2 minus x squared. Divide by 2 minus x squared. Say it with me, grade 11s. Divide by 2 minus x, coefficient of x squared. So say divide by 2 minus x squared. Say it with me. Say it again. Last time. Now you said it, so let's do it. Divide by 2. 6 divided by 2 is how much? 3. Now here's the minus 10. There's minus 10. Minus this x here in the bracket. Square it. 3 squared is how much? And there we go. There's your answer. You completed the square. X minus 3 all squared. Minus 10 minus 9 is how much? Right. Now it's a positive graph. It's a positive graph because your A is greater than 0. A is positive. So what will it have? A minimum or a maximum? It's got a minimum y value. A positive graph has got a minimum y value. And what's your q value? What's your minimum y value? Minus 19. It's the y value of your turning point. Your y value of your turning point is your minimum y value. I'll do 2 or 3 examples here just so that it polishes you so you know how it's done, minimum or maximum. We're going to follow the same thing, complete the square, but use the shortcut. Divide by 2 minus that x value squared. Divide by 2 minus x squared. I hope you guys remember yesterday's shortcut for inequalities. Pos or neg bet. Do you guys remember? Negative between positive or. Don't forget. Don't forget. Ends not cop. I'm going to show you many more now. We're coming, when we hit trigonometry, there's about 5 more. Okay, I want to show you another shortcut quickly. I want to show you. So this is a shortcut on completing the square. But before we get to that, let me give you 1 or 2 examples of this so that you solve it. Right, let's go. We're almost there. We're almost there. We're 10 past 10 already. I just want to show you these couple of shortcuts. I'm going to start officially with trigonometry after break. Right. So let's give you another one. Let's say g of x is equal to x squared minus 8x minus 30. Question. Right. G of x. I want the minimum or maximum y value. That's what the question asks you. So we want to get it in a form y equal a into x minus p all squared plus q. We want the q value. So basically, what do we want to do? We want to complete the square. Let's see if you can apply the shortcut I just taught you. If you can apply the shortcut, you're a boss. Then I'll give you one more after this, then we're done. Come on, you ought to be done now. Some of you who are sharp, you can look at it and actually do it mentally. Your brain's supposed to be firing on all 6 cylinders. So g of x is equal to, let's do that, minus 30. So x squared, x minus, so I need a number here and I need a number there. All right, what did I say? You guys said it 3 times. What did you say? Divide by 2. So 8 divided by 2 is how much? 4 minus this x value squared. 4 squared is how much? There's your answer. So your answer g of x is equal to x minus 4 all squared minus 46. So it's got a minimum y value of how much? Minus 46. Done. Yes or no? You like the shortcut? It saves you so much of time. Because I know in school what you would do is x squared minus 8x plus half times the coefficient of x all squared minus half times the coefficient of x all minus 30. Then you'll expand it. Then you'll reduce it. That's a half a page of calculation. You're getting it in 2 lines. Now let's see who's sharp. Let's see who is sharp. Now you can only complete the square when the coefficient of x squared is 1. So if there's a number like 2, you can take it out or divide everything by 2. You can only complete the square when the coefficient of x squared is... All right, you said it, nah? Okay. Let's give you one. And this... Watch here. Same question. Find the minimum or maximum value. F of x is equal to 3x squared minus 12x minus 24. Let's see how sharp are you. Come. Okay, can I do this one and I give you one after this one like this to do? No, let me show you how it's done. Oh, you want to do it on your own? Okay, all right. Yeah, let me show you this one, then I'll give you one more to do by yourself. Okay, watch here. No, I want to show you a nice clean of doing it. All right, watch here. We divide everything by 3. Right, wait. Watch here what I do. I'm doing it very differently to the way you guys do it in school. Very differently. So watch. But I'm doing it clean and neat. Watch here. It's an equation. So if I divide this side by 3, I must divide that by 3. Yes or no? So in my answer, I'm going to have f of x over 3 is equal to that, and that will cancel. What am I left with? X squared minus 4x minus 8. Now I complete the square here on this side. So f of x over 3 is equal to, let's complete the square, x minus 4 over 2 is 2, all squared, minus 8 minus 2 squared is 4. F of x over 3 equals x minus 2, all squared, minus 12. Yes or no? But I don't want f of x over 3. I only want f of x. So in my last step, I multiply this by 3 to cancel that. What I do to the one term, I must do to every term. So I multiply that by 3, and I multiply that by 3. Here's my final answer coming up. F of x is equal to 3 into x minus 2 all squared minus 36. So it's got a minimum y value of negative 36. Yay! Take it down. And I'm going to give you one to do like this. It's down already. Pure. I hope you were paying attention to it. Our learners are very talented. They can take down, understand, process, flippant supercomputers. Okay, so those of you who took this one down, now let's give you what odd numbers in it. How's our onliners there? Khalid, talk to us. Go for that. Don't worry, if there's odd numbers or fractions, don't stress. Just follow the same procedure. Like, but Hassan's getting comments from that side. Yeah, talk to us, Hassan. Tell us how's our online. Give him the mic there, please. Let me hear what's the comments coming in from the onliners. Yeah, they live there. You can use the above template.
Lots of shout outs here, Mr. K. We've got the Gias going out here. Shout out to Marcy, Wheat Peaks, and Mentor. Hey, the names is killing me.
Wheat
Yeah,
Peaks.
man.
Who the hell's
Wheat
name
Peaks,
is
man.
frick? Like really?
Yeah, Jaylin says away. Mango fish is on it again.
There we go. Did you do that in the first step? Right, now let's complete the square on this side. X minus. Now 5 over 2 divided by 2. Check it on your calculator. Is what? How much? 5 over 2 divided by 2 is how much? 5 over 4 all squared. Minus 3 minus, now square this. 25 over 16. 5 squared is 25, 4 squared is 16. So now, f of x over 2 equals x minus 5 over 4 all squared. Let's use our calculator. Minus 3 minus 25 over 16. Minus 73 over 16. Now, I don't want f of x over 2. I want only f of x. So, f of x is equal to, what am I going to do now, guys? Multiply by 2, multiply by 2, multiply by 2. So what's my final answer? 2. Don't forget this 2 in the front. Because your A value is 2. Your P value is 5 over 4. Minus 73 over 16 times 2. Minus 73 over 8. So it's positive. So again, this one here has got a minimum y value. It's got a minimum y value of how much? Minus 73 over 8. Got that one right? Well done, well done, well done. Okay, guys, it is past 10. Let's go for break. I will see you guys back in here at 10:50. I'm giving you 30 minutes. You're taking a 30-minute break. 10:50, we will resume. Have a lovely kusister, cup kusister, brekkie, Krispy Kreme, coffees, whatever you're going to, donut break. Enjoy your break, guys. You guys have been amazing. Onliners, are we back online there, Khalid? Are we good there? How's our comments coming in there? Talk to us. Everybody good? Are they blasting? Are they boosting with us? I'll see them back after the break. Yeah, we have to square this. 5 squared is 25. 4 squared is 16. Remember that value, you had to square it at the back. Pass.
give me one. It's fine. Pause on. Khalid. Pause on, team. Oh, was I prepared rather, yeah. Okay. Shukran. Khalid. Assalamualaikum, how are you? Well, your learners did well this morning, eh?
I was watching it.
What?
Couldn't sleep late anyway, so
Okay.
I joined online to watch it.
I had some rest this morning. I had some rest this morning. Are you able to get attendance register? Okay, that's for today. Shukran. We'll pass this around.
Give me one canola and give it to Glenda. And then they will come fix this stuff when they're
Okay,
done.
shukran. And cupcake. Khalid, stel koud hier, jy het boiled water.
Fine. I stopped at the supermarket this morning. I got me some of these Jacob 3-in-1.
We're traveling.
They good.
A traveling med scooter. Swami. Above your playground. Let's go. Couta's in the building. We will be sending the attendance register around. Kindly ensure that you do complete the attendance register. Let's start from here. You can just kindly pass it around. Name, school, contact details. You can pass it around. Thank you. So around 12:30 will be your lunch break. We will be feeding you. So look out for that. Right, Mr. Kouta, you can take the show away. We are ready.
Okay. Here we go. Grade 11s, I hope you enjoyed your comfort break. Welcome back to our onliners and as well as on our on-siters. You guys are absolutely amazing. And remember, we're beaming to the rest of the country. So they are watching you. They want to see. We need to disprove our critics as well. We want to show them that Mitchell's Plain and Cape Town has got the discipline, the willpower, the resilience, the grit, the dedication, and the commitment to excellence, getting 100% in mathematics. Destination distinction, guys. Destination distinction. So let me just open up this past paper. Here we go. All right. Okay, this paper doesn't open up with the diagram, but I think your finals are going to open up with the diagram. Okay. Quiet. Let's go. All right, so let's start. Besides working with that paper, let's start with the trigonometry. Let's start with the Cartesian plane. Let's say if cos theta is equal to 2/7. If cos theta equals 2/7 and theta is greater than 90 but less than 360, question number 1, find sine theta. Question number 2, find 2 tan squared theta minus 1. Right? No calculator. No calculator. Find theta. Correct to 1 decimal place. Number 4. Find sine squared 270 minus theta. No calculator. Okay. Question, answer. Okay. Now, whenever you see a situation like this, normally they will open up trigonometry by giving you that and maybe giving you a straight line there and giving you a pair of coordinates. If they don't, let's say they just start it off like this, just with the question, you know, pay attention. Right, the method that we're going to use now, watch here, I'm going to teach you a new acronym for the process. Here's the process. Scrap. Right. What does scrap stand for? Right. Pay attention. S, standard form and SOHCAHTOA. C, draw your Cartesian plane. R, look at your restriction to draw your triangle. A is just for and, doesn't stand for anything. And P is for Pythagoras. Use Pythagoras to complete. So whenever you need to draw it, these are the processes involved. You use scrap. Onliners in, you got your comments coming in there? Talk to us, guys. How are we doing there, onliners? We use scrap. So let's start. Standard form. There's standard form. Trig function of an angle equals a fraction. So it's in standard form. SOHCAHTOA. Cos is adjacent over hypotenuse. Cartesian plane. Let's go. There we go. Restriction. Greater than 90, there's 90, greater than 90, so you put there, it could be in quadrant 2, 3 or 4, but less than 360. But where is cos positive? In these 3 quadrants, in which quadrant is cos positive? Quadrant 4. So we have to draw our triangle in quadrant 4. So you got a double tick there. Why? The first tick gave us 3 options, and the only one where cos was positive was quadrant. So wherever you got a double tick, that's where you draw your triangle. That is angle theta. This is angle theta. Adjacent over hypotenuse, 2 over 7. We need our y value, so we use Pythagoras to do it. Right. So 2 squared, 7 squared, square on hypotenuse, is equal to the sum of the other 2 squares on the other 2 sides. So 7 squared is 49, minus 4 is equal to y squared. Y squared equals 49 minus 4 is 45. Y equals plus or minus the square root of 45. Now please, it's below your x-axis. Can it be positive? It has to be minus the square root of 45. Because it's below your x-axis. So it's got to be negative. So it can't be positive. In this case, y equals minus the square root of 45. Right, now we start answering the questions. You must draw the diagram. Onliners, did you get that? Onliners, did you get that? Don't worry about it. Okay, let's go. Find sine theta. Question number 1. So there's your questions, here's your answers. Question number 1, sine theta. Sine, we use SOHCAHTOA, opposite over hypotenuse. Opposite over hypotenuse minus square root 45 over 7. Easy stuff. Easy stuff.
Can we please make sure that we fill up the register so we know how many people are here for lunch?
Right, guys, let's do number 2. Let's do number 2. Right, answer to question number 2. Here we go. Right, let's answer question number 2. So we're done with question number 1. Number 2, we want 2 tan squared theta minus 1. Be careful. 2, this is tan theta squared minus 1. What is tan? Tan is minus root 45 over 2. Tan, opposite over adjacent. So this is 2 into, negative square is positive, root 45 squared is 45 over 4, sorry. 2 squared is 4 minus 1. 2 times 45 is 90 over 4 minus 1. Your final answer, 90 over 4 minus 1, 90 over 4 minus 1, you get 43 over 2. And there we go. As long as you don't put your answer in decimals, you'll be okay. All right. Now let's do question number 3. We want theta. So we're done with that. Now, for theta, you can use sine, cos, or tan. What do you want to use? Let's use cos. Cos theta equals 2 over 7. So theta equals, let's go. Shift cos 2 over 7. Shift cos fraction 2 over 7. 73,4. That angle theta, 73,4. The last one, they're testing you whether you know your rules of reduction. Please be very careful with the next one. Things are going to start getting a bit nasty after this. When we do reduction and we do identities and general solution, you're going to need to pay attention. Shh. Let's do the last one here. Sine squared, number 4. Be careful here. Sine 270. Remember, 90 and 70 changes the name. So sine 270, the name will change from sine to what? Cos squared theta. Now, many of you say, yeah, but sir, 270 minus is in your third quadrant. sign is negative there. But anything squared is always, a negative squared is positive. A positive squared is positive. So you don't need to check whether it's positive or negative for a square. So what is cos theta? Cos theta is 2 over 7 squared. Your answer is 4 over 49. 2 squared is 4, 7 squared is 49. Okay. Let's go into some reductions. Right. Now there are some rules of reduction you need to know. There are some rules of reduction that you need to know. Not some, many. Because if you don't know these rules, you're going to fail it. And each question is worth 7 marks. So let's go through the rules of reduction. The first one is our co-functions. The first rule is co-functions. You know that 90 plus, 90 minus, 270 plus, 270 minus, we're going to avoid using it. Not that we'll never use it, but we're going to avoid it. If it's there, what do? The name changes, like we did before. Sine will change to cos, cos will change to sine. 180 plus, 180 minus, or 360 minus on your Cartesian plane. We try and use it as much as possible because the name stays. That's your first set of rules. You have to know this for grade 11 and 12. Guys, if you don't know these rules of reduction, you will fail trigs hopelessly, openly. I'm summarizing all your rules on one screen. So you don't need to go back to your books. You don't need to go to textbooks. You don't need to look for these rules. I'm explaining to you all the rules on one screen. You got this, you got gold in your hand. I promise you. The second set of rules. What do we do with negative angles? So if we have sine of a negative angle is equal to minus sine of that angle, to remove the brackets. If you had tan of a negative angle, it equals to minus tan of that angle. But if you got cos, I'm going to put a star here, of a negative angle, it changes to positive cos of that angle. What's happening? You can't see. Why? Huh? Which symbol? Wait, let me see. Check out for me. That's a star. I can't hear. Tell me.
It's very simple. You say you can't see. I'm giving you a mic to tell Mr. Kota what is it that you can't see.
What about the logo? All right, are you okay now? Okay, anyway. Number 3, so that's your co-functions, that's your negative angles. What about your anti-clockwise angle now? This is important. Anti-clockwise angle. Now pay attention here. What if I told you sine x minus 270? Now what do we do with that? Right, I'm going to show you a way. I do it this way. Sine 270, I already know, will change to cos x, because 270 will change the name. Now I need to decide whether it is positive or... Right, now watch here. Sine is in which quadrant? Where does sine live? Quadrant 2. Shh. Guys, you need to pay attention to this. You're going to see this in our problems. You're not going to know what's going on. Now we're going to move 270 degrees anti-clockwise. So from here to here is 90. From here to here is 180. From here to here is 270. So it will land here. So sine is there. Sine, we look at the original, not the changed. Sine is here. We're moving 270 degrees. Where do we land? In quadrant 1. What is sine in quadrant 1? Positive. There we go. Let's do another example for you. What if I told you cos x minus 180? So cos 180 will stay cos x. Cos is in my fourth quadrant. I'm going to move 180 degrees anti-clockwise. So from here to here is 90. From there to there is 180. What is cos in this quadrant? Negative. Very good. Right, we got two more sets of rules. So we got co-functions, negative angles, anti-clockwise angles. What if you have an angle squared? An angle squared. An angle squared is always positive, like we saw before. So if I told you, for example, sine squared 270 minus x. So now, sine 270, will the name stay or change? 90 and 270, the vertical line, does it stay or change? Changes to cos squared x. Do I need to check whether it's positive or negative? No. Anything squared is always? There we go. And one more set of rules, guys. One more. One more set of rules. An angle greater than 360. An angle greater than 360. So let's say cos 480. Now, obviously, you got a minus 360 from the angle, because we know a circle is only 360 degrees. So this is the same as saying cos 480 minus 360 is how much? 120, yes or no? So now we need to reduce this in terms of our special angles. 120. Will I say 90 plus 30? Remember your quadrant, 90, 180, 270, 360. I told you 90 and 270, avoid using it. So this will be 180 minus which special angle? 60. Yes or no? Right. Now cos 180 will remain cos 60. 180 minus is in my second quadrant. Cos in my second quadrant is, and that's your special angle, your answer is minus half. Remember 30, 60, 45, special angles. 30, 60, 45, special angles. Now get ready. Get ready for war. I taught you the rules. Time to apply. Time to apply. The next two questions are worth 12 marks. Right, now wait. You were also taught, I want to go through your basics. So these were your basics. These are your basic rules, your 5 rules. We also know in identities, they might even combine something. What do we know in identities? What identities do we know? We know that sine squared theta plus cos squared theta is equal to 1. Yes or no? So, I mean, taken from here, we can also say that sine squared theta equal 1 minus cos squared theta. Yes or no? And we also know 1 minus cos squared theta is a difference of two squares. 1 minus cos theta, 1 plus cos theta. So you must be able to pick up this. You must be able to identify this in your problems. And the same with cos squared. Cos squared is 1 minus sine squared, and it's also a difference of two squares. We know that tan theta equals sine theta over cos theta. And we also know that tan squared theta equals sine squared theta over cos squared. These are just our identities. Okay. Remember, the simplest form in trigonometry, is sine and cos. If you can bring everything in terms of sine and cos, you've brought it to its simplest form. So we're done with the basics. Time for war. Are you ready for your 2 exam questions? 5 marks and 7 marks. 12 marks in total. 2 questions. 2 questions, 12 marks. So you'll get about 6 or 8 marks for that Cartesian plane, plus another 12 marks here. We're already on 20 marks. We must still do an identity. We must still do a general solution. We must still do a 2D trigs. That's going to build you up to your 40 or 50 marks for trigs. It's a very lovely topic. In fact, two topics are my favorite in math. My favorite, the whole of trigs and the whole of calculus in grade 12. That for me, it's the shit. Let's go. Come onliners, take a deep breath. We're about to go underwater. Exam questions. Simplify. No calculator. Show all calculations. 3, simplify. No calculator. Show all calculations. 3 cos 150 times sine 270 over tan negative 45 plus cos 600 for 5 marks. Here's your first 5-mark question. How's our onliners doing there? We're still getting the comments coming in there. Are they doing well? Are they surviving? Are they on fire? Are they cooking math today? Things happening there?
The students online are not chatting to us, they are chatting together. So you can talk to us, you can talk to Mr. Kota, so that he knows
Onliners, how are we doing? How are we doing? How are we doing? Today is not a time to be connecting with other people. It's the only thing you ought to be doing today is connecting with us and connecting with math. If you want to get 100%, forget about everything else.
Mango Fish says, no, we are here, and Ase Konosasa says that we are cooking.
Beautiful. Talk to us, guys. Talk to us. Let's go. 3 cos 150 is 180 minus 30 times sine 270, that's a quadrant. Just use your calculator. Sine, I think it's minus 1. Minus 1. They expect you to know it by memory, no problem. Cheat, legally. Over. Tan of a negative angle is minus tan 45. Plus cos 600. If I'm minus 360, I get 240 degrees. If I minus 360 from here, I get 240 degrees. So that's step number one. We're not yet done, because remember, we need to remove the brackets, convert everything to special angles, and I still got to reduce that. There's a double reduction there. Shh. Pay attention. 3. Cos 180, the name will stay, cos 30. 180 minus is in my second quadrant, cos is negative, times -1 over minus tan 45 is 1, special angle, plus cos 240 is 180 plus 60. 240 is 180 plus, right. Now let's remove the brackets. Negative times negative is a 3. What is cos 30? Sin 60, root 3 over 2. Divided by -1. Cos 180 will remain cos 60. 180 plus, there's 180. 180 plus is in my third quadrant. Cos is negative. Negative times this positive will make it a negative. We're not yet done. Let's convert the cos 60. So that's 3 root 3 over 2 divided by 1 minus cos 60 is a half. So 3 root 3 over 2 divided by 1 minus a half is a half. Now you can do this on the calculator as long as you don't put decimals. Times 2 over 1 times 2 over 1, your answer is 3 square root 3. You can check it on your calculator. And you will get 5 marks for that. Step by step, item for item. You need to go home, you need to practice on this until you can do these problems without anybody helping you. That's when you call it mastery. Talk to us there, Khalid. Give us some feedback there. The next one. Those of you who have taken this one down, you can start with the next one already. Did any of our onliners get that one right, Khalid?
They haven't commented yet, so as soon as they comment, I'll let you know.
Is there a question? Yes? Why? Take the... Quiet. Wait. It's fine. Okay, quiet guys. I need to hear the question. Thank you. Shh.
Sir,
Yes.
my question was, why did you reduce cos 60 degrees?
Why did I use cos?
Why did you reduce?
Why did I reduce what?
Cos 6 degrees.
Cos what? Cos 60. It's a special angle. Cos 60 is a half. It must be reduced. What are your special angles? 60, 30, 45. So cos 60 has got to be simplified into a half. Check on your calculator. Cos 60 is a half. You can't, they say you need to simplify without the use of a calculator. So you got to bring all of this into fractions. So tan 45, you know, is 1. Sin 45 is root 2 over 2. Sin 60 is root 3 over 2. Sine 30 is a half. You can use your calculator as long as you don't put decimals. Right? Still not understanding? Can I do this problem? Okay, let me ask you something. Can I do this problem with 1 minus cos 60? Can I continue with this problem with 1 minus cos 60? No. What is cos 60? So, I 3 root 3 over 2 over 1 minus cos 60. I got to reduce it. I got to, using my special angles. Cos 60 is a half. Okay, you'll have to go back to her. Okay, the rest of you, while I sort the learner out here, you continue with this. Take the next one down. For 7 marks,
Sir,
simplify.
You were not
Yes.
answering my question.
Guys, I can't hear a question. And you're going to need to
Guys,
speak
please
up.
settle down. Please settle down so that we can all hear the question.
All right, please speak loud into the mic.
Sir, you were not answering my question.
What was your question?
My question was,
Yeah.
why did you reduce cos 60 degrees? Whereas in the equation, it was given that it was plus cos 60 degrees.
It was plus cos 600. The original question said 3 cos 150 times sine 270 over tan negative 45 plus cos 600. Right. Shh. Let's do it again. All right, watch here. All right, the rest of you, if you don't want to do it again with me, you can do this one. Let me do this one again with her. Right. 3 cos 150 is 180 minus 30. Sine 270 is minus 1 over minus tan 45 plus cos 600, we minus 360, I get 240. You agree with that step? No, I'm talking about the girl who asked the question. Right, pick up your hand if you're understanding, right? Yeah, keep your hand up if you're understanding. Okay, now watch. 3 cos 180 will become cos 30. 180 minus is in my second quadrant. Cos is negative. Agreed? Times minus 1 over minus tan 45 is 1. Agreed? Plus cos 240 is 180 plus 60. Agreed? Right. Now let's reduce that. Shh. Negative times negative is a positive. 3 cos 30 is sine 60. The same thing. Root 3 over 2. You can check it on your calculator. Over 1. Cos 180 will remain cos 60. And 180 plus is in my third quadrant. Cos is negative. Yes or no? Very good. So now, so you left with 3 root 3 over 2 divided by 1 minus cos 60 is a half. Yes or no? Correct. And that's exactly what we did. 3 root 3 over 2 divided 1 minus a half is a half. Times 2 at the bottom, times 2 on the top. Your answer is 3 square root 3. There we go. You understand? Lovely. Double dolly. double dolly ratebe. Titi.
Quentin says they don't understand if there's no triangle.
Huh?
They say they don't understand if there's no triangle.
Ah, then use your calculator, brah. If there's no special angle triangle, come on. If you don't know it by memory, your calculator you have. As long as you don't convert it to decimals, you will be all right. You don't need to memorize it. It's good to know it, but if you don't know it, it's fine. We got the FX82 or 991 or 991 plus. Right, let's do this last one. Let's do this next one here. Come on, guys. Shh. Let's go, let's go, let's go. Question, answer. Step by step, item for item. We're going to sort that out. 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 Each part needs to be sorted out. You leave out nothing. Right, let's go. Let's do it together, guys. I'm not doing it twice. I'm only doing it once, so you better follow. Tan 180 will remain tan x. 180 minus is in my second quadrant. Tan is negative. Times sine 90, the name will change to cos x. 90 plus is in my second quadrant. Sine, don't look at the changed one, look at the original. Sine in my second quadrant is what? Positive. Over. Sine of a negative angle. The only one that becomes positive is cos. So sine of a negative angle minus sine of that angle. Minus sine y. Cos 90, the name changes to sine y. 90 minus is in my first quadrant, everything is positive. Now, be careful. Negative divided by a negative is a? Right. Here's an identity here. Tan. I said we need to convert everything to sine and cos. So what is tan? Sine x over multiplied by cos x over 1 divided by sine x minus sine y times sine y is sine squared y. Not sine y squared. It's sine squared y. Now simplify. Algebra. Cos x and cos x will cancel out. Sin x and sin x will cancel out. So I'm left with 1 minus sine squared y. Now this is my identity. 1 minus sine squared y is what? Cos squared y. And there's your final answer for 7 marks. Okay. Do you guys want to try one more by yourself? One more? Right. Those of you who got this one, those of you who have taken it down, let's go. Simplify. Sine 180 plus a times tan a times sine 90 plus a. Khalid, how's our onliners doing? Talk to us. I wish I could see them and see all the comments coming up here on my screen here. I would be talking to them every second. Tan 180 plus a. Times cos of negative a. Times sine of negative a. They okay there? They on fire? They cooking it? They smashing it?
Yeah, they are calculating.
6 marks.
Where is Andisiwe? Just lift your hand, I'll come.
Here we go, guys. Exam question, come on.
Andisiwe, where are you?
Right, come guys, come guys, come guys. Let's go. Each component needs to be transformed. You need to remove all those brackets according to the rules. Sine 180, sine A. But 180 plus is in your third quadrant, sine is negative, times tan A, sine A over cos A. Sine 90 will change to cos A. 90 plus is in my second quadrant, sine is positive, divided by tan 180 will remain tan A. And tan A we know is sine A over cos A. So I'm just doing it one shot here. Tan A is sine A over cos A. 180 plus is in my third quadrant, tan is positive. Times cos of a negative angle is positive cos A over 1. Times sine of a negative angle is minus sine A over 1. Now the fun starts. Here comes the algebra. Negative divided by a negative is a positive. Sine A over cos A divided by sine A over cos A. Tan A over tan A is gone. Cos A and cos A is gone. Sine A and sine A is gone. Everything is gone. That means everything divided by itself. What's your final answer? 1. Yebo. I would love to, guys. I would love to, but we got so much of work to complete for today. If I gave you for every problem 5 to 10 minutes, we'll die. But anyway, let's go into identities. Let us go into identities. Guys, you can try all of these at home. You've taken it down. You can watch the video. You can practice it. Mastery will take place at home. Understanding will take place here. Right, let's do identities. Identities. Right. I'm going to teach you another acronym here. Listen. So we knew SCRAP, S-C-R-A-P, standard form, Sokotoa, Cartesian plane, restriction, and Pythagoras. Now, who does identities? Ali does identities. Who's Ali? Not Muhammad Ali. Step number 1, AL, algebra. Step 2, look for your identity. The left-hand side will equal to right-hand side. So who does identities? Ali does identities. Ali does identities. And I'm going to show you now. We're going to do some worked examples. Grade 11s, you need to pay attention here. Ali does identities. And then I'm going to give you another acronym on the process of general solution. So you'll never hopefully get a general solution one wrong. Right. I'm erasing. Where are you going? I need a co-pilot here. Khalid. I need to talk to my onliners. Okay, give the mic to Hasanain. Maybe Hasanain can give me the online comments. Give the mic there. Otherwise, I'm blank here. I got no eyes and no voice. Sharp. There we go, Hasanain. Hasanain can take over from Khalid. Thanks, Hasanain. How are we doing there, Hasanain?
I thought you divorced me, eh? I'm no more a person of interest, but I'm glad that you included me in the conversation. It's all good.
Prove.
Co-pilot.
Prove that sin x plus cos x all squared is equal to 1 plus 2 sin x cos x. See, Hasanain, if I don't have anybody here with a mic here next to me, I'm blind on the online side.
When
My
is your birthday?
on-siters,
When is your birthday, Mr. Kauta? Maybe I can gift you with an additional phone so you can see all the love that our online cohort is giving us.
Maybe you
here.
guys need to provide me with a small tablet here on the side. How about that?
I got a Panado tablet for you. How's that? Will that do?
Bring it. Bring it.
No, for your birthday, we need to gift you. We need to upgrade you with some of the tech.
Right. Prove that sin x plus cos x all squared is equal to 1 plus 2 sin x cos x. So let's start on the left-hand side. So on the left-hand side, let's do algebra. In algebra, let's do Ali. Algebra. Sin x plus cos x into sin x plus cos x. Yes or no? We're not yet done with the algebra. First, outer, inner, last. My two first terms is what? Sin squared x. My two outer terms plus sin x cos x. My two inner terms plus sin x cos x. My two last terms plus cos squared x. So sin squared plus cos squared is 1. There's your identity. We'll finish with the algebra. Now let's do identity. Sin squared plus cos squared is how much? 1. Plus 1 sin x cos x plus another 1 sin x cos x is what? Plus 2 sin x cos x. There we go. Therefore, left-hand side is equal to right-hand
Question.
side. There we go. Yes.
Tara Lee wants to know, why don't you use opposite angles sub-ended or equal? I don't know if that makes sense to you.
No, where is that coming? That must be from this morning.
Okay.
That can't be from here.
No, this is a minute ago. So maybe there's a delay.
No. Yeah, maybe they joined late, or maybe they saw the question early in the morning and decided to ask the question now, but I don't know what's going on that side.
You know what? Some of us are all tired.
Yeah.
And some of us, our brains are fried, you know?
Let's go, let's go, let's go. So there we go. Right, let's do another example. Then I'm going to give you 2 to do from a past paper. We're going to do 2. So here's one. This is a model. It's a template.
Here's a challenge to you, Mr. Kauta, from Nabila. Sir, give us something that's going to make us think.
Yeah. It's
Challenge
coming up.
accepted.
It's challenge accepted. Challenge accepted. But wait, let me first show you this one. Prove that 1 over 1 plus sine x plus 1 over 1 minus sine x is equal to 2 over cos squared x for 4 to 5 marks. This is not yet the challenge. This is still level 2. This one here that we did here was level 1. This is a level 2. Don't worry, level 3 and 4 next. Let's find it for Nabila.
Mr. Kauta, did you watch that movie, To Sir with Love?
Yeah?
Yeah, so lots of this.
We're getting lots of love from our onliners.
Yeah, let's see.
Amazing, guys. Amazing.
Yeah, look, I have to admit, you know, our online cohort as well as the online, they've been with us. So, Khalid, they deserve a round of applause from you and Kauta. You can give them a one-hand round of applause. Round of applause there, Khalid.
There we go. Let's give them.
Now you guys are awesome. Fire.
Are you ready? Let me hear you. Are you ready? Let's get ready to rumble.
Kauta, did you have like a full night's rest or multivitamins?
I am boosting on 3 hours of sleep. 2 o'clock to 5 o'clock, 2 a.m. to 5 a.m.
So by the time we finish here, myself and Khalid's going to have to pull you out on the stretcher.
Bruh, I got more energy now than when I started.
Hey, Khalid, we must be ready.
Let's go. Let's start on the left-hand side, guys. Left-hand side, algebra. Algebra. We're finding the LCD. 1 plus sine x, 1 minus sine x. Right. We divide and multiply, we divide and multiply. So 1 plus sine x, 1 plus sine x cancels out. What are you left with? 1 minus sine x. 1 minus sine x times 1. We're doing algebra. LCD, lowest common denominator. Right. 1 minus sine x times 1 is 1 minus sine x. We're doing the left-hand side. Plus 1 minus sine x, 1 minus sine x will cancel out. What am I left with? 1 plus sine x. That remains. 1 plus sine x times 1 is what? There we go. So that's your LCD. Now, minus sine x plus sine x gives me 0. Right, grade 1s, 1 plus 1 is over. This is a difference of 2 squares. 1 times 1 is? Positive times negative is? Sine x times sine x is? Right, so I'm done with my algebra. Let's look for your identity. Ali does identities. 1 minus sine squared is what? And there's it. Left-hand side is equal to right-hand side. Okay, so you asked for something heavy. All right, let's go. I think you're going to cry. 9 marks. Nabila, are you ready for 9 marks? Nabila, guys, Nabila asked for the next one. Onliners, we got Nabila to thank. Woohoo! Yeah?
You get full marks if you didn't show all the steps.
You must show the steps. You got to show the steps. You got to show. You can't jump in these questions from question to answer. There's no way. It's done item for item, step by step. Are you ready for the next one? Take a deep breath. Dang. Nabila, you asked for it, brah. What you ask, you will get. Nine marks, have fun. 9 marks, have fun. I'm going to take an oxygen break. You can talk to the rest of them. Take it away, Khalid. Talk to our onliners there. Tell them about our competition. Oh, Hasanain's got the mic. Hasanain,
Yeah, no,
5
Khalid.
minutes, I need some oxygen.
Yeah. Knock yourself out there, Mr. Kouter. So there we go, guys. So we're moments away from our lunch break. The next break will be our lunch break, but we'll get Khalid to keep us entertained in terms of some of the information. Kindly do ensure that you have completed the attendance register.
Now all of them seem to Iphi iMandela mayisihlabelele igwijo kwalo. Nje uhamba isixesha kuthiwa cula kaMande Mandela. Niyatre Uphi? Akho umuntu ufuna usihlabelela ingoma nobe iyi-1. Ndiyayazi iMandela soze ingahlabeli iMandela.
Ntoni? Ingoma fethu. Yethu sonke nebhuti esayicula sonke. Fun. Salendwenda ay kitchen yabona nje. Oh. Bitte liebe fit. Ja? Abelungu fit. Ngathelo. Akamandela. Kodwa abantu. Yeah. Yeah. Anya. Ithini?
Akho umuntu ukwazi uhlabela amandwendwe bathi bayabhesa bona so bakwazi ukuhlabela. Uphi? Abafuna ucula aba bantu.
Awe mama vulela mandwendwe, vulela mandwendwe, vulela mandwendwe, vulele. Awe mama vulela mandwendwe, vulela mandwendwe, vulela mandwendwe, vulele. Awe mama vulela mandwendwe.
Thula mntana mukhathazwa yintoni? Thula mntana mulilela ntoni? Thula mntana mukhathazwa yintoni? Thula mntana muli ndiphethwe inhloko. Phethwe inhloko mna.
There we go, there we go. Khalid is the man. Give him a nice round of applause. Here we go, here we go, here we go. I bet nobody even tried it. All right, onliners, are we ready? Khalid, talk to us. How's our onliners doing there? Onliners want to be here. Those that are in want to be out, and those that are out want to be in. It's like marriage. Right, let's go. 1 minus 2 sine squared A is what? Cos squared A. There's your identity staring at you. Now here's the trick. Check this out. Come, I show you something. You guys want to see some magic? Mathematics. The number 1 is sine squared A plus cos squared A is 1 plus 2 sine A cos A. Now be careful. Check here. Wait. Sine squared plus cos squared is 1. Now this is equal to cos squared A over, let's rearrange this, sine squared A plus 2 sine A cos A plus cos squared A. I just rearranged it. Right. Shh. Quiet. I'm not yet done. Cos squared A. What's happening there? What's happening? Yo, I'm failing. Hey, wait. 1 minus, it was actually 1 minus sine squared A. Let me just double check. Just give me a second, wait. I just want to double check the question that I took it down right. Give me a second. Oh no, it was right. 1 minus 2 sine squared A over 1 plus, so 1 minus 2 sine squared A is not cos squared A. Wait. Okay, relax, we got this.
Inganathu lapha. Ulambe lapha.
Right, guys, work with me here. Shh, quiet. The number 1 here. The number 1 is also sine squared A plus cos squared A minus 2 sine squared A. Pay attention. The number 1 is sine squared plus cos squared. So I'm going to again 1 sine squared, so I'm left with cos squared A. 1 sine squared A minus 2 sine squared A is minus 1 sine squared A. Shh, pay attention, grade 11s. Right, so the number 1, I broke it up into sine squared plus cos squared. Minus 2 sine A, there we go. Shh, the number 1 here again, sine squared A plus cos squared A plus 2 sine A cos A. So what, again, I'm just explaining it to you. 1 sine squared A minus 2 sine squared A is minus 1 sine squared A, and you're left with cos squared A. I've just rearranged this. Now pay attention. Pay attention. Cos squared A minus sine squared A is the difference of two squares. It's going to be cos A minus sine A into cos A plus sine A all over. This is a quadratic equation. We're going to break this up. It's going to be sine A times sine A to give me sine squared A. It's going to give me cos A times cos A to give me cos squared A. Both of them are positive, so we put positive. Now that cos A plus sine A, cos A plus sine A, those two brackets will cancel out. I'm left with that on my left-hand side. There's nothing more I can do with that. It's in its simplest form. Please, you need to follow. Now we need to do the right-hand side. Now we need to do the right-hand side. Now pay attention. Yes. Guys. All right, let's, okay, right, quiet. Right. I think maybe he's representing the sentiments of many out there. Right, okay, let's go. Watch here. Now you need to pay attention. You need to pay attention, otherwise you're going to be lost again. Right, here goes. Put your pens down. Right, thank you. Now look here. The number 1. The number 1. Isn't it sine squared A plus cos squared A? The boy who's... pick up your hand, I can't see you. Right. Sine squared plus cos squared is 1. You understand that? Right. Pay attention. I'm talking to you, but I'm talking to the whole country. And if you're telling me you're going to understand in every step, it means that everybody will understand. So you understand that the number 1 is sine squared plus cos squared. Good. You do understand that this number 1 here at the bottom is also sine squared plus cos squared. Yes or no? Yes or no? Right. Now let's look at the numerator. Pay attention. Guys, I need absolute silence. Because I'm not going to explain it again. I'm explaining it this for the last time. Follow. Okay, here's a cos squared A, right? Here's cos squared A. I'm copying and I'm pasting it here. Cos squared A. 1 sine squared A, these are like terms, minus 2 sine squared A gives me what? Minus 1 sine squared A. Yes or no? Good, good, good. All over. Watch here. There's a square, that's not a square, so I'm moving this to the back. So watch here. Sine squared A, there, plus 2 sine A cos A, which is the middle term of my quadratic equation, plus cos squared A. I'm going to put a tick there. You understood? I just rearranged it. Good. Now pay attention. This x squared minus y squared is the difference of two squares. Yes or no? And this here at the bottom, the first is squared, last is squared. That's a quadratic equation. All right. Now we factorize. What are we doing now? All right. So difference of two squares, cos A minus sine A into difference of two squares, cos A plus sine A, yes or no? Over quadratic equation. Let's go. Sine A times sine A to give me sine squared A. Yes or no? To get cos squared A at the back, I'm going to say cos A and cos A to give me cos squared A. Agreed? Both of them are positive, so I put positive, positive. So sine times sine is sine squared. Cos times cos is cos squared. My FOIL, first outer inner last. Sine A cos A plus another sine A cos A will give me my 2 sine A cos A in the middle. Yes. Now, what's identical here? Cos A plus sine A, cos A plus sine A, or sine A plus cos A cancels out. Yes? Understood. Lovely. So we are only left with this on the left-hand side. That's where we stopped. Thumbs up? Thumbs up. Now let's go to right-hand side. Shh. Come on. Wait, you need to follow now. You need to follow. 1 over 1 minus tan A is sine A over cos A. Right. Divided by, yes, divided. So I'm just moving it to the side. Divided by 1 over plus sine A over cos A. What's happening there, guys? You need to pay attention, otherwise you're going to ask me to re-explain, and I'm not. You need to pay attention and you're disturbing the rest. This is important work. It's from a past paper. Now follow. So this divided, there's it. Numerator divided by denominator. Now let's do the LCD. Lowest common denominator, lowest common denominator. What's your LCD here? Cos A. Yes or no? 1 into cos A times. Cos A times 1 is cos A. Cos A divided by cos A is 1. 1 times sine A is sine A. Right, wait, divide. Now let's do this. LCD here. What's your LCD there also? Cos A. Very good. You're following nicely. 1 into cos A times 1 is cos A plus cos A into cos A once, 1 times sine A is sine A. Now pay attention. Now we tip in times in algebra. So cos A minus sine A over cos A multiplied by cos. Can you see where we're going with this? Guess what? In the next step is our final answer. There we go. Now we cross multiplying. That and that cancels out. Numerator times numerator, cos A minus sine A over denominator times denominator. Left hand side is equal to right hand side. There we go. In its simplest form, left hand side is equal to right hand side. How many of you died there online? You off? Okay. Right. Onliners, how are we doing?
Mango Fish is asking 6-7.
6-7. 9 marks. Not even 6-7. 9 marks. 9 marks. We're having lunch at 12:30. It is 12:15. I'm going to give you one last one. Come on. Yeah. The next one's also, guys, you 1 kilo one, so here goes. Those of you who have taken this one down, I'm just taking out the question. You can already start with the next one. Prove that tan squared theta minus sine squared theta into cos squared theta over sine squared theta plus 1 all over tan squared theta is equal to 1. 7 marks. Hopefully you don't see something as hectic as these, but at least we've done it. So if you practice on it and you master it, you will be able to get it. You want to convert everything to sine and cos. That's what you want to do. You want to convert everything, remove the brackets, convert everything to sine and cos, and you want to prove that left-hand side is equal to right-hand side. You want to use algebra. Right. Can I raise the left here? Come guys. Sort out this in a bracket. Sort out that in a bracket. Remember we use BODMAS. Brackets first. Simplify. Make this one fraction. Make that one fraction. Divide that. Remove the tan squared. Make it sine squared over cos squared. Come on, and use the algebra. Let the algebra work for you.
Nabila is seeking forgiveness for challenging you.
You forgiven, Nabila. You made the country suffer today.
Khumelo Poco, where are you? Ubuhlumelo, guys.
Right. Am I raising this? Are you still writing on the right-hand side? Oh my Lord, you haven't even taken down the next question still. You guys are playing. You are playing, guys. Now, it's always good maths practice that when you have a fraction over a fraction, you say divided by and move the denominator to the side. Good to work with. It's easier to work with. We don't want to work with a fraction over a fraction. Move the denominator to the side. All right. Guys, this is not for the faint at heart. It's for those of you who are activated and locked in. If you're here to mess around and your mind is everywhere else and you're just here to pass time, just to be with your friends, FYI, this is not even going to benefit you. This is the time you should have been sitting at the beach. This room here of 400 learners is only for those who are locked into math. We've got that burning desire to ace math. You're here to mess around. You feel like, whatever happens, what will be, will be. Some of you already got an intention to dropping to diet maths, maths light at the end of the year. Maths 0. Have fun.
No sugar.
No sugar. Right, let's go. Left-hand side. Let me help you with the first step. Tan squared theta is sine squared over cos squared. Yes or no? Yes. Minus sine squared theta over 1 into cos squared theta over sine squared theta plus 1 over 1 divided by, I'm only working on the left, so it's divide. This means divide. Divided by tan squared is sine squared theta over cos squared theta. Yes or no? Now watch. Let's do the LCD here. Let's do the LCD there. Times, turpin times cos squared theta over sine squared theta. Shh. Pay attention now. Put your pens down. Put your pens down. Right. LCD here. LCD there. Let's go. What's your LCD here? Cos squared theta. Yes or no? So cos squared divided by cos squared is 1. 1 times sine squared is what? Is sine squared theta. Minus 1 into cos squared times. Cos squared times sine squared is sine squared theta, cos squared theta. Shh. What's your LCD? So that's my first bracket. Second bracket, what's my LCD? Right. Sine squared divided by sine squared is 1. 1 times cos squared is cos squared. Plus sine squared divided by 1 is sine squared. Sine squared times 1 is sine squared. Now, in my brackets, watch here. Guys, stop messing around. Cos squared theta. Right. Look here. I got 2 terms here. What's common in the 2 terms? Sine squared theta. What am I left with? 1 minus cos squared theta. Here, sine squared theta plus cos squared theta is what? 1 over sine squared theta. Now let's get rid of that bracket there. Shh. We're left with sine squared theta. 1 minus cos squared is what? Sine squared theta. Identity over cos squared theta times 1 over sine squared theta times cos squared theta over sine squared theta. Now we are done. Cos squared and cos squared will cancel out. Sine squared and sine squared will cancel out. Sine squared and sine squared will cancel out. What's your answer? And isn't that your right hand side? Finish. Done. Problem solved. Again. Hell no. Hell no. I asked you at every point, do you understand? You say yes, yes, yes. At the end you say again. Skabapal. Wahlanya. Highest common factor there, identity here, identity there, LCD in the first step, cancel, equal to right hand side.
Abantu bebesitya ixhego ngebreak amakhalibhodi abomvu kuthiwa agcwele all over the place so
Okay, let's do, we got 8 minutes left before break. Let's start off with 2 general solutions. 2 general solutions before lunch. We're going for lunch at 12:30. It's 12:23. We're going to go for lunch till 1:15. Right, those of you who have taken, some of you are still writing here, leave that up. Right, for those of you who are done already, find the general solution. Five to the power 10x is equal to 125 for x being an element of 0 to 360 degrees for 5 marks. Give the general solution. Basically solve for x. Solve for x with the general solution. General solution, you know, for sine and cos is plus k times 360. For tan is plus k times 180. Very easy. You can already see the relationship between 5 and 125 as an exponential equation. Come, it's easy. Straightforward. It's a no-brainer. It's a no-brainer. That's your question. Here's your answer. 5 to the power 10x. We know 125 is 5 to the power 5 and 5 will. What am I left with? 10x is equal to, x will equal to, now go shift tan 3. Shift tan 3, what's it, 71,56? Yeah, boy, 71,6. 71,56, 71,6. Attach your general solution, plus k times 180, where k is an element of integers. Quiet. Guys, but they also give you a restriction. So where is tan positive? Tan is positive in quadrant 1 and quadrant 3. Who said quadrant 2? Just anything that comes to your head, you just say. So this is quadrant 1. Quadrant 3. Why are we choosing quadrant 1 and quadrant 3? That is where tan is positive. Or x is equal, in quadrant 3, it's 180 plus. Anytime an angle lies in quadrant 3, it's 180 plus. 71,6 plus k times 180, where k is an element of integers, so x is equal to 180 plus 71,6 is 251,6 plus 180k, or k times 180, where k is an element of integers. There's your general solution. That's your one answer. That's your second answer. One for quadrant 1, one for quadrant 3. I ask you another general solution. One more. 3 more marks. Right.
Kutheni ngingxame kangaka ninkazathile?
To sin x cos x minus sine squared x equals 0. Give the general solution for 7 marks. It's not difficult. Whenever you see a square in the problem, you got to factorize and it becomes a quadratic equation. And then you got to give 2 solutions. Question, answer. Right, we got 2 minutes. Right, follow. You want to try it on your own or you want me to do it for you? We got 2 minutes left. 1 minute. You want me to do it for you in 60 seconds? Right, gone in 60 seconds. Your highest common factor there is what? Sin x. Your highest common, we're factorizing, highest common factor is sin x. What am I left with? 2 cos x minus sin x equals 0. So I got 2 factors, it's a quadratic equation. So sin x equals 0 or 2 cos x minus sin x equals 0. So x is equal to shift sine 0 is 0 degrees plus k times 360, where k is an element of integers, or x is equal to 180 plus k times 360. That's your first solution. Your second solution on this side. Minus sine x will equal to, take the cos on the other side, minus 2 cos x. Negative divided by negative is a positive. Divide the side by cos x. What I do to the right, I do to the... So what is sin x over cos x? Tan x is equal to, x is equal to shift tan 2, shift tan 2, 63,4 for 10 plus k times 180, where k is an element of integers. There you go. You'll get yourself 7 marks for that. And we did it in 1 minute. Boys and girls, that brings us to the end of the second session. We are now going for lunch. Where's the lunch being served?
The
Where's
lunch,
the lunch being
the
served?
lunch will be on this side, exactly where you came out yesterday. Yeah.
Right, guys, go collect your burgers and your drinks. Lunch is being served. We will resume at 1:15 p.m. 1:15, we are back in. Enjoy your break, enjoy your break, enjoy your break. How's our onliners there? 2D trigs and Euclidean. Let's go, let's go, let's go, let's go, let's go. I see everybody still coming in. Grade 11s, come through, settle down. Swami. Okay, is there water somewhere? Is there a bottle of water? Okay, yeah, you know what I'll do? Let me just top it up from here. Ay, ay, ay. Okay, grade 11, settle down. Are we live there? Right, we okay there? Okay, are we live? Put up with the whiteboard. Let's get the whiteboard up. Our onliners. Here we go. Welcome back. Guys, let's get started. We are back, grade 11s. Right, let's start off with 2D trigs. Quiet. Now we are doing non-90-degree triangles. Take this down. Guys, if you're going to miss this, you need this for grade 11 and 12. Thank you. If you're walking in, please be silent and say, thank you, grade 11s. Guys, you guys have been absolutely super amazing. We've been together for 2 full days. I think you all deserve a nice round of applause. Well done. Nice. This is the way we do math. Okay. Time to lock in, guys. Okay. We all know for a 90-degree triangle to solve it, we use SOHCAHTOA. For a non-90-degree triangle, you're either going to be using the area rule if they use the word area in it, or the sine rule, or the cos rule. Now you've been introduced to non-90-degree triangles in school. Okay, let's go. Right. If they gave you a triangle, if they just gave you a triangle like this, and they told you this is triangle ABC, and they gave you that as 50 and that as 60 meters, and they told you that this is 40 degrees. And they told you to calculate the area of this triangle. Right. Area of a non-90, this is a non-90 degree triangle, is equal to half of a side times another side times sine of the included angle. So area will equal to half of 50 times 60 times sine. Included angle is 40 degrees. Now area is equal to, let's go, 50 times 60 divided by 2 multiplied by sine 40, we get 964,18 meters squared. Quiet, you need to pay attention here, guys. You need to pay attention. This is the area rule. This is the area rule. Our onliners, everybody all back in. Khalid, how are they doing there? Everybody fired up for the last session?
Super King is logged in and Mango Fish says that we are back.
You are back. You are back. Welcome, 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 guys. Right. Now, what if the reverse? What if they gave you the area and you needed to find the angle? Now, what if they gave you the area to be 964,18 meters squared, and now they didn't give you this angle? You need to find angle B. So we use the same rule, but we just make angle B the subject of the formula. So let's do that one. So this is a straightforward area rule. So again, because they gave us the area, the minute they give you the word area, you're going to say area. Let's go back. Area is equal to half of a side times another side times sine of the included angle. So area is 964,18 is equal to half of 50 times 60 times sine of B. Now we need to find B. So all we're going to do, we're going to say 964,18. 50 times 60 is 3,000. Divided by 2 is 1,500 sine B. So sine B, divide by 1,500, divide by 1,500, boom, boom. Sine B is equal to 964,18 divided by 1,500. 0,6427. Now we are looking for an angle, so we use a shift key on our calculator, guys. So shift sine 0,6427. Shift sine. And we must get 40 degrees. 0,6427. I get 39,99. I get 39,99, blah, blah, blah. So B is equal to 40 degrees. There we go. That's the reverse.
So will there be time for probability?
I hope so. I hope so. Okay. So this was the area rule, and you only use the area rule if the word area is used in the question. The minute they use the word area, either to find the area or area given, you use the area rule. Now, we got the sine rule and the cos rule. Now let's apply the sine rule and the cos rule to sort out a triangle. Then we go into 2D shapes. So you need attention, you need to follow. You're going to need this for grade 11 and 12. Whatever you have learned this weekend, or whatever you have learned in grade 11, you will be using every single concept plus more in grade 12. Now imagine, I don't want to put anybody in the eyes, but we've got an A student, or we got A students of grade 12 sitting here amongst us, and they joined us here just to go through the grade 11 content, because they realized that, when are you writing? Tomorrow. So we got A students in grade 12 that are sitting here in a grade 11 workshop, and they are writing their matric finals paper 2 tomorrow. Do you now understand how important grade 11 work is? Without this work, there's no way you're going to understand anything in everything in grade 12 is built on this. These are your building blocks. And not only your building blocks, whatever you're going to be tested now, you tested in grade 12 as well. So like I said, sitting here amongst us today in this very workshop are grade 12s. A students, not C students, not D students, we just need to pass students. We got A students, grade 12, sitting amongst us here today. Just because they realized the importance of grade 11 work for tomorrow's paper. And they wanted an intensive revision of grade 11. Correct? Correct. So the quicker you realize how important this work is, the quicker you're going to get your distinction. And the quicker you realize that you need to listen to me word for word, and you need to pay attention and hang on to every word I tell you, and you need to learn every process I show you, every shortcut I show you, every hack I show you, every technique I show you, the better for you. The quicker you'll get your distinction. Let's take another triangle. Now we need to solve a triangle. So let's put a triangle that looks like this. Okay. I tell you that this is 50. This is 40 degrees. This is 100. That's 50 meters, that's 100 meters. This is triangle PQR. Find angle P. Sine P over 100. Let's see if this one works. In fact, make this 80. Make this 80, make that 80. Let's see if this one works. Right. Now when you're given two sides and the excluded angle, we use what we call the sine rule. Now I just made this one up. Don't write. Let's just hope that these values work. So we're going to say sine P, sine of an angle over its opposite side, is equal to sine of any other angle over its opposite side. Now I just want to check something. Yes, it will work. Right. So, sine of an angle over its opposite side is equal to sine of any other angle over its opposite side. So, sine P over 100 will equal to sine 40 over 80. So, I want P. So, sine P times this side by 100, times that side by 100, we're going to get 100, we're going to get 100 sine 40 over 80. So P equals, now use the shift key on your calculator. So now we're going to go shift sine fraction 100 sine 40 over 80. We get 53,46 degrees. Right? Now obviously this is not drawn to scale. This is not drawn to scale. You can see that's an obtuse angle. This is greater than 90. So I think in this case P will equal to 180 minus 53,46. Let's see what we get. 180 minus 53,46. 126,54. This angle here, because it's obtuse, it's greater than 90, will be 126,54. Now, that's the sine rule. Now, let me show you how to apply the cos rule. I'm just showing you application. You need to learn the proofs of it for your exam, and the proofs are in your textbook. Learn the proof of the area rule, the sine rule, and the cos rule. Okay. So the sine rule, we use it when two sides and the excluded angle given. You can see two sides and the excluded angle, or two angles plus any one side. That's the sine rule. Let's apply the cos rule. Let's apply the cos rule. Let's draw a triangle, any triangle. Right. I tell you that this is 80, and I tell you that this is 50. I tell you this is 35 degrees. Triangle D, E, F. Find the length of DF, the last side. Now here you can see it's two sides and the included angle. So whenever two sides and the included angle given, or if three sides are given, we use the cos rule. Now let me show you the cos rule. Let me show you the cos rule. Right, so in our answer, find DF. The question here is find the length of DF. Right, so your last side squared, watch here. Your last side squared, AB squared, is equal to, now we're dealing with that, that, and that. So it's 80 squared plus 50 squared, the sum of the other two sides squared, minus 2 times the product of the two sides, 80 times 50, cos of the included angle. There we go. So the last side squared is equal to the sum of the other two remaining sides minus 2 times the product of the two sides, cos of the included angle. So all we do now, AB will equal to the square root of 80 squared plus 50 squared minus 2 into 80 into 50 cos 35. You're going to see how we apply it to the higher order questions that we are about to come up just now. And here's your, take your calculator. Take your calculator. So we're going to say the square root of 80 squared plus 50 squared minus 2 into 80 into 50 cos of 35, close brackets, equals 48,44. So AB, we use a calculator, we got 48,44 meters. It's the length, 48,44 meters. So this is what we say the cos rule. When do we use the cos rule? When two sides and the included angle given, there we go, a side, and the included angle to find the last side. To find the last side. Okay. Now, stay with me here. Stay with me here. Now we're going to do 2D trigs, but we're going to be applying sine rule, cos rule, but instead of having alphabets, we're going to have symbols. Alpha, beta, theta, x, y. You use the same rule. The same principles apply, but instead of them giving you numerical values, they are giving you variables or symbols. So let's erase this. Okay? Now, take the next diagram down. Now watch this. Watch this. Okay, let's go there. Let's do that. Let's do this. Let's do that. That's a 90-degree triangle, so we'll use SOHCAHTOA. Then we got this triangle here, which is non-90. So we'll either use the sine rule or the cos rule here. Pay attention. Right. They tell you that the angle of depression here, remember that is parallel to this. That's 90 degrees. This is triangle PQRS. They tell you that this is angle theta. That is angle theta. This is x. That is alpha. That is angle beta. Now the only difference is here they're not giving us values. They're giving us symbols. Right. They call this PR. Right. Show PR. Show that PR is equal to x sine beta over sine alpha tan theta. Okay. Very easy. It looks difficult, but very, very simple. All our alphabets are in triangle 2. We want to bring these alphabets from triangle 2. The main thing we want to do is rename the common side. What do we want to do? Rename the common side. That's the step. Right. So what's the common side here, guys? QR. It's the common side between the two. So let's start in triangle number 2 where all the alphabets are. Why? Because PR is in triangle 1. What they want us to find is in triangle 1. Everything else is in triangle 2. So I need to move those alphabets into triangle 1. And the only way to move it in a non-90-degree triangle is the sine rule or the cos rule. That's the vehicle to move it. That is the vehicle to move it. So let's start. Triangle 2. Watch here. Triangle 2. See how easy is it? Because you've got a sine there and a sine there, that already gives us a clue. We have to use the sine rule. So watch. QR QR over its opposite angle over sine alpha is equal to x over sine alpha. So I want QR on its own. So I'm going to multiply. This is the sine rule. I'm using the sine rule. So I multiply this side by sine alpha. I multiply that side by sine alpha. Boom, boom. What am I left with? QR is equal to x sine. No, this is x over QR over sine beta. Sorry. Okay, sorry, my bad. Sine beta, sine beta, sine beta. There we go. Let's go again. QR over sine beta is equal to x over sine alpha. So times this side by sine beta times that side by sine beta. QR is equal to x sine beta over sine alpha. So there we go. We've renamed the side. X sine beta over sine alpha. That's what QR is now known as. Now we go into triangle number 1. Triangle number 1 is 90 degrees. So there, what am I going to use? SOHCAHTOA, yes or no? Right. I need PR, and I need QR, the common side. So what is this of theta? Opposite over adjacent is what function? Tan. So we're going to say tan theta equals PR over QR. This is opposite over adjacent. I need PR on its own, so times QR. So PR is equal to QR tan theta. PR is equal to. Instead of QR, what can I put? What did I just find out? What is QR known as? There we go. X sine beta over sine alpha times tan theta. And there's your final answer. Done. Done. This is triangle number 2. This is triangle number 1. That's triangle number 2. We use the sine rule. Triangle number 1, what did I use? SOHCAHTOA. We're going to do 2 more. We're going to do 2 more of this, then we're done with this. It's 1:45 already. And then we'll end up with our Euclidean. And it's not difficult at all. You just got to know your theorems. You just got to know your theorems. Those of you who are done with this, rename the common side. That's the aim of the game. Okay. Those of you who are done with this, take the next one down. Okay, take this, that, this, and that. Right. Triangle A, B, C, D. That's 90. This is not 90. And they tell you that this is on the floor, this is a vertical pole. That's a dotted line. And they tell you that that is parallel to that, and the angle of depression here is angle theta. This is x, that is alpha, that is beta. This is AD. Right, show that AD. Here's the question. Here's the question. Show that AD equals x sine alpha over sine alpha plus beta cos theta at the bottom. We do the same thing. Relax. Don't stress. It's worth 7 marks. Don't panic. Don't panic. Okay. Right, let's start in this round. What did I say? What is the purpose? What is the aim? What's our first step? Rename the common side. What's your common side? Right. Now we got a sign in here, we got a sign, so it already tells us what rule are we going to be using. So that's triangle 1, that's triangle 2. If that is theta, that is theta. Alternate angles. But we're starting in triangle 2. Now, in triangle 2, because we're going to be using the sine rule, BD over sine alpha will equal to x over sine of this empty angle here. Do we have this angle here? Do we have this angle here? Yes, we do. Sum of angles of a triangle, it's 180 minus alpha plus beta. Yes or no? Now pay attention. It's not difficult. Shh. Let's go. BD over sine alpha. We're starting in triangle. What triangle are we starting in? Very good. We're starting in triangle 2. It's non-90 degrees, so we're going to be using the sine rule. Shh. Pay attention. BD over sine alpha is equal to x over sine, its opposite angle we just got, 180 minus alpha plus beta. Now let's reduce this. That's why we have reduction. Reduction is basically based on a triangle with sum of angles of a triangle to get rid of the 90, 180, 270 or 360. So let's reduce that 180 minus. So BD over sine alpha equals x over sine 180, the name will stay, sine alpha plus beta. 180 minus is in my second quadrant. Sine in my second quadrant is positive. Now I want BD on its own. So times sine alpha times sine alpha. What am I going to get? BD equals x sine alpha over sine alpha plus beta. And there we go. We don't think we're right. We know we're right. We already got that in our final answer. Right, so I'm just going to write it here on the side. We just found BD. We just found BD to be x sine alpha over sine alpha plus beta. That was our common side. What was that? Common side. Now we go into triangle 1. We need this side AD. We need AD. Here we go. We need show that AD. And we need the common side BD. So AD and BD with regard to angle theta, opposite, hypotenuse, adjacent. AD and BD is adjacent over hypotenuse. So from SOHCAHTOA, what is adjacent over hypotenuse? Sine, cos, or tan? Cos. That's where we're going to get the cos from in our final answer. Right, now watch. Now let's go back into triangle 1. We were in triangle 2, we're done with triangle 2. Let's go into triangle 1. Simple. Easy stuff. Light work. Triangle 1 is 90 degrees. So cos of theta is equal to cos adjacent BD over AD. Opposite over adjacent. SOHCAHTOA. It's cos. Right. I want to make AD the subject of the formula. I want AD, so let's do it together. Flip this side, flip that side. AD over BD equal 1 over cos theta. So I want AD, so times BD here, times BD there. So what is AD equal to? BD over cos theta. Therefore, here's your final answer coming up. AD equals, instead of BD, what must I put? X sine alpha over sine alpha plus beta. Cos theta is in my denominator. I leave it there. There's your final answer, 7 marks. So I gave you 2 in terms of the sine rule. Let's give you 1 in terms of the cos rule. We'll do one last one in terms of the cos rule and we're done with this. We then go into Euclidean. The last topic for today. Hopefully. Okay. We're moving on good time. Okay, take this diagram down. Let's see, it goes like this, goes like that, like that, like that. Very similar to the last one, but different things are given. That side is equal to this side, that's x. This angle is angle alpha. That's 90, that's h. This is P, Q, R, S. This angle here is angle beta. Right, this is h. H the height, not h the hypotenuse. Please, you must be able to differentiate between h the height and h the hypotenuse. Right, I'm erasing here. Show that h the height. Show that h the height, which is PQ, is equal to x tan beta square root 2 into 1 plus cos 2 alpha. Six marks. Khalid, how's our onliners doing? They're very quiet. Nobody's saying a word. You mean they're so locked in at this time of the day?
Yeah, they are locked in. Oyisa Fezani says, oh, now I get it.
Let's do this together. Do you want to try it on your own? Come on, come on, rename the common side. Rename the common side. But you got a cos in it. So if this is x, that is x. That's an isosceles triangle. That is alpha, that is alpha. Then this angle is 180 minus alpha plus alpha is 2 alpha. I'm just helping you out. So here you go. You got two sides and the included angle. Come on. Come on. Go for it. Use the cos rule to rename the common side. Use the cos rule to rename the common side. I'm going to give you guys 5 minutes to try this one. I promise you, you get this one right, you've understood the work. There's going to be a little bit of a trick in algebra, but nothing major, guys. Nothing major. I'm taking 5 minutes. Khalid, you can take it away with our onliners.
Ikhona isophumelela namhlanje? Ngathi akuzoqalwa ngani namhlanje so. No singavula meeting discuss because if nakuqalwa abakufutshane so ngoba nabakufutshana. Sanokulwa. Let's have a discussion. Abantu baseParliament nebagxeka xa besilwa phaya but nani same thing. Oyisophumelelo meza ne? Ke ngoku isophumelela kutheni ngambi ngenyawo xa 2 minutes. Ukhona esam apha? Esam yabulisa usiyasanga andiyazi noba ngubhuti na but sabe yabulisa ubhuti siyasanga uson-in-law. Arena Park Secondary School eDurban uyabulisa uMango Fish no Mr Sukraj. Hlumelo uyabulisa uBhutsihle. Umechana Somalia. Zakaria, Zakaria, Zakaria. Umechana Somalia. Why Tino Sethi umalume wenu uyabulisa uthi unibukele batshana. South Peninsula High School ikona? Ayikho babukele online. So a shout out from a super gang. Ndive ubhuti phaya ezitoilet esithi amntana bendimnika inamba yami izolo akakandibulisi. Ndibawela nomkhomba ngoba nimjongile ngoku. So ke sithi ubunikwe inamba khawudubulise. Uba unadatha uze kum ndinayo ipassword yeWi-Fi. Uboyitumelo ukhona apha. Uthi uEmihle uzamphinda ugrade 11. Oh, uhlumelo ngubhuti, then usihle ngusisi. Denze mistake uxolweni guys. What's up, nigga? A shout out to Imas Pumelele High and Princeton High. Ubhuti Mbasa uyabulisa ku-Onwa eGlendale.
Okay, guys, we are back, we're back. I hope you guys, onliners, I hope you got the answer there. Let's get the screen up. Summit, we're just waiting for the screen. There we go. All right. So now, QS squared. Now it's going to get a bit hectic. You need to follow. In terms of the algebra. So now, QS squared is equal to x squared plus x squared, that squared plus that squared, minus 2 into x cos of 180 minus 2 alpha. That's your cos rule. Right, pay attention. Let's do this. Now comes the algebra. After substituting into your formula, in any topic in math, your algebra takes over. So let's do the algebra. QS squared, 1x squared plus 1x squared is what? 2x squared minus 2x squared. Cos 180 will remain cos 2 alpha. 180 minus is in your second quadrant. Cos is negative. Negative times this negative will give me a Right. So there we go. Now please, in your next step, these are two separate terms. This is one term. That's one term. You can't say 2x squared plus 2x squared is 4x squared. So we have to take out the highest common factor, qs squared. What's your highest common factor? 2x squared. What's left over? 1 plus cos 2 alpha. Yes or no? So qs is the square root of 2x squared into 1 plus cos 2 alpha. Qs is equal to, the only perfect square here is x squared. So the square root of x squared is x, so we take it out. X. The square root of x squared is x. What am I left with? The square root of 2 into 1 plus cos 2 alpha. So there's the x, there's your x. There's this whole thing underneath the third, there's the whole thing. So we know we're on the right road. The only thing we're missing now is tan beta. And that we're going to get from triangle 1. So take that down. Learn this one for grade 11 and 12. Now we want h from triangle 1. So now we're going to be using SOHCAHTOA. And this already tells me what to use. 10. My answer already tells me what to use. We're almost there, guys. We're almost there. Hang in there. 2 days of intensive math. Now let's go into triangle number 1. Let's go into triangle number 1. And let's use tan beta. We're now into triangle number 1. Triangle PQS. Triangle PQS is 90 degrees. So tan beta is equal to h, there's your h, over QS. Opposite over adjacent. SOHCAHTOA. But what do we want? We want h on its own. We want h on its own. So times QS times QS. So what do I have? I have h on its own is equal to QS, and QS will cancel, so you're left with QS tan beta. So h equals, instead of QS, I'm going to put x tan beta square root 2 into 1 plus cos 2 alpha. And there we go, there's our final answer. And we are done. No, not for the day. Not for the day. Right. Now, grade 11s, you need to know your theorems for circle geometry, Euclidean. Now, do you want me to give you the theorems? Must I go through the theorems with you? Oh, my Lord. There are 11 theorems. Okay. I'm erasing here. Right, put the heading Euclidean geometry. All right. What's the first theorem you know about circles? What's the first theorem you know about circles? What? Right. The exterior angle of a cyclic quad is equal to the interior opposite. Yes or no? The exterior angle of cyclic quad equals the interior opposite angle. What's the second one that you ought to know? Come on, still talking about a cyclic quadrilateral. No, wait. Firstly, we're still busy with a cyclic quad. All 4 points touch. The opposite angles of a cyclic quad, opposite angles of a cyclic quad add up to? Very good. What's the third one you need to know? Right. Shh. Please pay attention. Pay attention. Equal chords subtend equal angles at the circumference. The next one that you got to know. Shh, guys, grade 11, this is important because when I'm done with this, I'm throwing you into the deep end with 2 past papers. We're going to be working through them and we're going to be applying all these laws to that. Right. The next one that we need to know is the bow tie. All 4 points or the butterfly. All 4, or the scissor. You can call it a scissor, a bow tie, a butterfly, however you recognize it. Shh. What do we call this? Angles in the same segment at the circumference are equal. Please. Shh. So it's the bow tie. Quiet, quiet, quiet. That's number 4. Let's do number 5. Very important, the next one. Very important. You get tested in almost, the grade 12s will tell you how important this one is. And they even ask you to prove this one. Line drawn from center of a circle to the midpoint of a chord meets it at 90 degrees. Line drawn, that's not a radius, it's just a line drawn from center of circle to midpoint of a chord is 90 degrees to the chord. The next one, very important as well, you've got to know its proof. Number 6. Right. Now, number 6, there are 2 of them that mean exactly the same thing. You need to pick up these shapes. Shh, pay attention. This one is called, what I call this one was the bow tie. This one is like a spearhead. You know a spear? Asachai. Arrowhead. We all know this one. Exterior angle at center is 2 times angle at. Right now, it can either look like that or it can be a quadrilateral from the center. This is not cyclic. Cyclic means all 4 touch the circumference. Here again, exterior angle at center is 2 times angle at circumference. So we can call this 6A and 6B. They're the same. Exterior angle at center, let me just write it here at the bottom. Exterior angle at center equals 2 times angle at circumference. Let's do number 7. You still taking down number 5? Number 7. Right, pay attention. Pay attention. Now you have a diameter. And a diameter subtends a 90 degrees at the circumference. So we call this angle in a semicircle. At the circumference is 90 degrees. Let's do number 8. Right, pay attention. Now what happens if you have a bow tie from the center of a circle? Angle at center is 2 times angle at circumference. Angle at center is equal to 2 times angle at circumference. Let's go to number. Very important, this one too. A radius is 90 degrees to a tangent. That's a radius. That's a tangent. Tangent is a straight line touching the circle at one point, side. O is the center of the circle. So radius is 90 degrees or perpendicular to a tangent. The next one, very important. The tan chord theorem, and you've got to learn its proof. Now you must have a cyclic triangle, if there is any word like that. I'm just calling it cyclic because all 3 points must touch the circumference. And now you got a tangent. So angle between tangent and chord, is equal to the angle subtended at the circumference in the alternate segment. So we call this the tan chord theorem. One more, and we are done. Then we go into application. The last one, two tangents meeting at a common point outside the circle. Two tangents meeting at a common point outside the circle are equal in length to the circumference. Two tangents meeting at a common point. Outside are equal in length to where they touch the circle. Now, when you're writing your reasons, you can just write it two tangents meeting outside the circle, dot, 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 and close. You don't need to write the whole theorem down. Okay, here we go. Let's apply. Let us apply. Okay. Now it's not difficult at all. I'll show you how it's done. 2, 4, 6, and 3 is 9, and 4. This question is 13 marks. Now remember, in grade 12, your Euclidean geometry is 50 out of 150 for paper 2. 50. It's big. And half of it, or 70% of it, is the circles. So if you don't know this, you're going to get 0 for paper 2 in grade 12. Right, for those of you who took this one down, let's go for this one. From a past paper, take this diagram down. Let's all do it together. Okay, you're going to have to draw it with me. See where I start. From there to there. From here to here. From there to there. From here to here. From there to there. From the center of the circle to there. And that's it. Let's see. E, D, G, F. E, D, G, F. O is the center of the circle, O1, O2. H. Where's 9? There's a 90 degrees, 1, 2, 3. 1, 2, 3, and that is 90 degrees. This is E1, E2, E3. In the diagram below, DF is a diameter, so O is the center. DF is perpendicular, chords EF and GF are drawn. EGF is 55. EGF is equal to 55 degrees. EGF, 55 degrees. Right, let's put your questions. I'm going to put all the questions down and we're going to answer them one by one. Find, giving reasons, the size of. Find, question number 1, angle D. Question number 2, angle O2. Question number 3, angle E2. Question number 4, E3. Shh, guys, grade 11s, I need silence there, please. Shh. Right, determine the length of OH. Question number 5. Find the length of OH if the diameter of the circle is 10, if the diameter of the circle is 10 units, and GE and GE is equal to 9,4 units. Right, 2, 2, 2, 3, 4. 2, 2, 2, 3, 4. Total 13. Take this diagram down, guys. Onliners, let's go, let's go, let's go. Now, you have to give a reason. Now, please, okay, now put your pens down. Let's do a little bit of discussion here, quickly, a quick discussion to show you how it's done. Look for radii. Look for radii, because radii will always make isosceles triangles. You will always be using isosceles triangles in a circle. Now look for your shapes, look for your theorems. And start with the known, moving to the unknown. You never start from the unknown moving back. Start from the known and try and link it to the unknown. But using your mark allocation as a guide. Very important. 1 mark or 2 marks, direct link. 3 marks, 1 curve, and we get back there. 3, 4, 5 marks, now we're talking, we need various ways to get to our answer. So angle D, these are all 2 marks each. So I'm guessing the first 3 are direct links. Let's look at D. Right, so we know. What did I say? Even before I start with this, let me look for my radii. There's a radius. That will equal to that, will equal to that. So I already know there's 2 isosceles triangles. There's an isosceles triangle, there's. So that means E3 is equal to F, and E1 plus E2 is equal to D. What do I also know? This is a diameter, and a diameter will subtend a 90 degrees. Yes or no? Okay. Also look for exterior angle equal to interior opposite. Because we're dealing with triangles, everything to do. And then if they give you parallel lines, look for alternate or look for corresponding angles. Agreed? Right. Let's start with angle D. Is there a direct link between what? Start with the known. Start with 55. Is there a direct link between 55 and D? Yes. Here's the bow tie. Can you see the bow tie? Can you see the scissor? E, D, F, G. E, D, F, G. That's your bow tie. So angle D is equal to 55 degrees, angles in the same segment. Right, number 2. So the minute you get this as 55, go to your diagram and put 55 there. Right. Number 2, O2. I want O2. Now pay attention. This here is equal to that. O2, angle O2 is now, remember something, if this is equal to that, that means this angle is equal to that angle there. It's an isosceles triangle. So exterior angle will equal to sum of interior opposite angles. So watch here. OD equals OE radii. Therefore, triangle ODE is isosceles. Therefore, angle D equals angle E1 plus angle E2. The angles opposite the equal sides. Angles opposite the equal sides. Therefore, angle O2 equals 55 plus 55. So this is also 55. O2 is equal to 110 degrees. Exterior angle of a triangle equal to the interior opposite angles. What's angle E2 equal to? Come, E2 is not difficult to find. Shh. There, that's E2. This angle here on the top is E2. Now, if that's 90, that's 90. So, exterior angle, again in this triangle, EHO. Exterior angle is equal to the sum of the interior opposite. So, we can find E2. We got 110, we got 90. 110 minus 90, how much is E2? 20 degrees. Let's do it together. Right, we need angle E2. So we got our first 6 marks. Right. So angle O2 is equal to angle H2 plus angle E2. Why? Exterior angle, this triangle here. Exterior angle of a triangle is equal to the sum of your interior opposite angles. O2 is 110 degrees. H2 is 90 degrees plus E2. So 110 minus 90 equals E2. Therefore, E2 equals 110 minus 90 is how much? 20 degrees. So let's go here. Angle E2 is 20 degrees. So this whole angle was 55. So if this, quiet, if E2 is 20 degrees, this whole angle is 55. That means E1 is 35. Now they want angle E3. Now there are 2 ways of finding it, either here, or you can say diameter subtends are 90 degrees. The whole of angle E is 90. Angle in a semicircle. The whole right, I want E3. Question number 4. Now we know the angle DEF is equal to 90 degrees. This entire angle is 90. Why? Diameter subtends are 90 degrees. Angle in a semicircle. Therefore, E1 plus E2 plus E3, that's the whole of angle E, is equal to 90. Now we got E1, 35. We got E2, 20. Plus E3 equals 90. So E3 equals 90. That's 55 minus 55. Angle E3 equals 35 degrees. Now we know that this is also equal to 35 degrees because that's also an isosceles triangle, the 2 radii. The radii here, that side is equal, angles opposite the equal sides. Right. We're on to the last question for 4 marks. Find the length of OH If the diameter is 10 and GE, where's GE? And GE equals 9,4. Very interesting question. Let's see if you can apply your mind. It's not difficult. It's not difficult at all. Right. I just want to erase here. Let's just do a bit of a cleanup here. Right. Find the length of OH. So let's highlight OH. Where's OH? OH is that. There's OH. If the diameter is 10, DF is 10. Come, guys. Right, let's go. Hey. We're answering question number 5. Come, onliners. Let's go. Right, if the diameter is 10, that means each radius is how much? So that's 5. Let me just write it out nicely for you. So that's 5. This entire radius is 5. The entire radius is 5, and that radius is also 5. Okay. Now pay attention. Attention. Now look here. What else do they tell us? They tell us that GE is 9,4. Watch here. GE is 9,4. Line drawn from center of circle perpendicular to the chord bisects the chord. That means that piece is equal to that piece. That means EH. Watch here. EH is equal to 9,4 divided by 2. 4,7? 4,7 units. Why? Line drawn from center of circle. Line drawn from center of circle to midpoint of a chord. Bisects the chord. So this is 4,7. This is 4,7. And we got this here to be 5. Come on. OH now. This is a 90-degree triangle. We just used Pythagoras. Watch here. So, EO squared is equal to EH squared plus OH squared. Pythag. We're looking at triangle EHO. Triangle EHO. So EO squared is 5 squared. EH squared, we just found EH to be 4,7 squared plus OH squared. They want us to find, so here we're getting to our answer. 25 equals 4,7 squared gives you how much? 22,09 plus OH squared. So 25 minus 22,09 equals OH squared. (2,91). OH squared equals 2,91. So OH, that's our final answer. The length of OH is the square root of 2,91. OH is equal to the square root of 2,91. Boom. 1,7. units. And there we go. You can get 4 to 6 marks for that in your exam. I'm giving you another one. So take this one down. Yo, we only got 15 minutes left. It's 2:45 already. We're at the end, guys. We are at the end. Next week, grade 10, bruh.
Same place.
Same place. Back in Cape next weekend.
So Pumelela will go first. Izawukhwela ne-Philippi High.
The hell?
Enhle. Uzawukhwela ne-Philippi High ne? Ukhangele.
Take this diagram down, guys.
Ama grade 11 before exam now alala esikolweni. Ongama grade 12 only. Oh, okay. Ubona uhlobo enilele ngalo apha. Ni comfortable. So we are streaming live on YouTube, on Facebook. So immediately at 3 p.m. when Mr. Kota says pens down, the video will be available for download. If there's a place where you didn't understand or something like that, you can go over it. Even if you understood, you have to go over and over and over. That is mathematics.
Right, here we go. Take that diagram down. Oh, come on. Okay, take this diagram down, guys. This is the last one we're doing. It's the last problem for today and we are out. Thank you, grade 11s. Find with reasons 3 other angles equal to x. Question number 1. Find 3 other angles equal to x. Question number 2. If ATVC is a parallelogram, hey, guys at the back, thank you. Prove that AT equals BT. And the last one, Determine the size of x. Find the value of x. Mark, 6, 5, and 2. 6 marks, 5 marks, 2 marks. This brings us to the end of our session after we answer these 3. We're almost there, guys. It's now 47. 13 minutes left. We're at the end. Hang in there. You've been here for 2 days. Shh. Guys, thank you. Right, let's go. Find 3 other angles equal to x. Now, they gave you parallel lines. So if this angle is equal to x, then B1 is equal to x. So question number 1, angle B1 equals x. Alternate. Please, grade 11s. Girls. Thank you. You're disturbing everybody else. You're stalling the program. B1 equals x, alternate angles. Now, these 2 sides are equal. So V1 equals x. Angles opposite the equal sides. V1 equals x. Angles opposite the equal sides of a triangle. One more angle equal to x, guys. One more angle equal to x. So we got this to be x. We got that to be x. Those 2 are not parallel. Those 2 are not parallel. We need one more angle equal to x. This is a tangent. AT is a tangent. It touches at one point. So what will T2 equal to? X. Angle tan chord theorem. Angle T2 equals to x. Angle T2 equals x. Tan chord. There we go. Statement, reason, statement, reason, statement, reason. You got yourself 6 marks. Agreed? Right, number 2. If ATVC is a parallelogram, that means that side is parallel to that, and that side there is parallel to that side there. Prove that AT equals BT. AT equals BT. Now, in order to prove that this side here is equal to that side there, we need to prove that these 2 angles are equal. Because if those 2 angles are equal, then the sides opposite them will also be equal. Are you guys listening to me? This is important. If in order to prove that AT equals BT, that means we need to prove it to be an isosceles triangle. That means I need to prove that angle B is equal to angle A. We're not proving sides equal. We're proving angles, and because the angles are equal, their opposite sides will be equal. So now, where do we start? Let's start here. What's angle B3 equal to? This is a cyclic quadrilateral. So angle B3 is equal to the whole of angle V. B3 is equal to the whole of angle V. So angle B3 is equal to V1 plus V2. Exterior angle of cyclic quad. So what is B3 equal to? 1x plus 1x is how much? 2x. Now I need to prove that A is also equal to 2x. If I can prove that A is 2x, that means these two angles are equal. That means these two sides will be equal. Now they told us that this is a parallelogram. So angle A is 2x. Why? Opposite angles of a parallelogram. Angle A is equal to angle V1 plus V2, which is also 2x. Opposite angles of a parallelogram are equal. So therefore, AT equals BT. The sides opposite the equal angles of a triangle. And you will get 5 marks for that. We almost at the end. The last, and we're moving on fantastic time, it's 5 to 3. We're on to the last question. Find the value of x. Come on, that's so easy. You got 2x, you got 2x, you got x. Sum of angles of a triangle equal to 180, yes or no? So let's answer the last one. We're done now. We are now officially done. Let's do number 3. So we're going to say in triangle ABT, 2x plus 2x plus x equal 180. Sum of angles of a triangle. Five x is equal to 180. X is equal to 180 divided by 5. 36 degrees. We are officially done. Boys and girls, wait. You guys have been. We got another 2 minutes left. Just to 5 minutes. Just to chat to you quickly for 1 minute. Give us 60 seconds of your time.
So
we just want to say thank you so much. You guys, over the past 2 days, you guys have been absolutely amazing. Thank you to our onliners. Guys, you all deserve a nice round of applause. You guys are amazing. 2 days of pure maths. I hope you guys enjoyed your stay with us. And we hope to see you. Good luck for your exams. And we'll see you in 2026 in grade 12. Destination, distinction, destination, destination. There we go. Thank you so much, guys. Love you guys. Lots of love. We will see you guys in 2026. Thank you, onliners.
Nkosi sikeleli Afrika maluphakanyisa uphondo lwayo izwa imithandazo yethu Nkosi sikelela thina lusapho lwayo